Now I would like to invite Dr. PASBAN himself from the Department of Physiology, University of Karachi, to moderate the session.
First of all, I would like to welcome you all to this conference. I would like to invite Ali Hassan to perform the prayer, and then we can start. Ali Hassan, please.
Bismillahirrahmanirrahim. قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد صدق الله العظيم.
We be having the national anthem now. Kindly stand in the respect of the Ladies and gentlemen, please join me in giving a warm and enthusiastic welcome to the remarkable Professor Dr. Karachi. As a visionary thinker, Dr. Karachi has consistently demonstrated an unwavering commitment to excellence, innovation, and the pursuit of knowledge. Dr. Your presence here today is a reflection of your outstanding achievements and impact that you have made on countless lives. We really anticipate your insights and wisdom that you will undoubtedly share with us. Thank you for gracing us with your presence, and we clearly await to see the moments where you will enlighten us with your knowledge. Let's give another round of applause to the incredible Dr. Karachi. Now, please.
And a very beautiful morning of Karachi, and very warm welcome to you. On the behalf of our Honorable Vice Chancellor, respected Chief Guest, neuroscientists, speakers, and early career researchers, and those who are participating from the online or Zoom or virtual. I'm feeling great, in fact, I'm feeling immense pleasure to welcome you all in this 9th Annual Neuroscience Conference. I'm excited and I'm really delighted that this year the conference is taking place at the University of Karachi under the umbrella of Department of Biochemistry and in collaboration with PASBAN, Pakistan Society of Basic and Applied Science. I'm sure that this conference will provide an opportunity for the attendees, for the participants to get exchange ideas on the daily research, and they also have good collaboration and networking in future. I'm sure the participants will enjoy the talks. We have very valuable people present here, and you will be having in the coming days. And today we will talks and we will have some very informative talks in the sessions. As a chair of this 9th Annual Neuroscience Conference and as a translational neuroscientist, I believe the conference like these are basically the you can say the need of these days, and because the brain disorders are the greatest health challenges in the world is facing these brain disorders, and we are going to shed some lights on these disorders in these types of conferences. I am wishing the success of this conference and also wishing the future of the Department of Biochemistry. Thank you so much. And again, thank you. Thanking our Vice Chancellor for the provision of this newly renovated hall for the facilitation of this conference or this event. Thank you so much and have a kind of enjoyable day.
Thank you so much, ma'am. Ladies and gentlemen, please join me in welcoming the distinguished Dr. Sadat Ahmed to the stage. Dr. Ahmed's contribution to the field of neuroscience has left an indelible mark, inspiring many and pushing the boundaries of knowledge and innovation. We are truly privileged to have her with us today to share her insights, expertise, and wisdom. Dr. Sadat Ahmed is the president of PASBAN and assistant professor at Department of Physiology at Karachi. Let's give a warm round of applause for Dr. Sadat Ahmed.
Thank you, Fazan. I am very much privileged to host this conference at University of Karachi, and this is the first time that as President PASBAN elect, I am organizing the conference, though last 8 years have been a roller coaster journey for all of us at PASBAN. And I would like to introduce PASBAN as a only neuroscience society of Pakistan, which is working only on the connection between the clinical, applied, and basic neurosciences. So we are actually trying to not only facilitate to fill the gap between the clinical neuroscientists, the applied neuroscientists, and the basic neuroscientists, but also those basic scientists and clinicians who are more interested in working on different parts of neurosciences. For example, there are biochemists, there are pharmacologists, there are biomedical engineers. Last year, we had a lot of people from public health domain. We had a lot of people from medical lab technology. We had a lot of people from the AI and computer science as well. And in the next conference, which was the 10th Annual Neuroscience Conference, we will be having a separate session on the artificial intelligence and everything. So this 9-year journey actually facilitated more than 5,000 participants in different neuroscience sessions. That is, Annual Neuroscience Conference has been attended by more than 5,000 participants. We had the conference at Aga Khan University, 5 conferences hosted at Aga Khan University. We had 2 conferences hosted one at NUST and one at Dow University of Health Sciences. One was virtual due to COVID, so these were all the conferences. We also had some advocacy programs like with the Dana Foundation, International Brain Research Organization. We had some awareness sessions and capacity building workshops and mental health camps as well. The core sessions other than Annual Neuroscience Conference of PASBAN are Essential of Neuroscience Certificate course. We had 5 Essential of Neuroscience Certificate course up to now, and almost 3,500 students have actually been certified in that Essential of Neuroscience course. Then we also have a webinar series with the name of News, and we actually conduct it monthly or alternate every month. And we had almost a lot of international neuroscientists, including Nobel laureates, who actually delivered those lectures on every other month of the, and this is the whole webinar series that we are actually growing into. Professor Dr. Zafar is director of News. So we have a long list of people who are supporting from Pakistan and outside Pakistan to PASBAN. But I'm very much thankful to one person who is actually the founding president of PASBAN, Professor Dr. Akhar Imam. Besides being a great neurosurgeon, he is a great clinician, but what actually connects us is his interest in the basic sciences and the core, hardcore neuroscience, where we do things on the cells and neurons. So it is much more fascinating that how clinical aspect can be coordinated and how we are all on this platform. I am very thankful for Professor Dr. Khalid Iraqi's support, because this auditorium was actually in the renovation, and I was actually bothering sir again and again that we are going to have an international conference, and sir, where we should do it. So sir was here last, I think a day before yesterday, and he was actually standing here and making it possible that we can open or inaugurate this whole session. Let me actually explain you about the history of this auditorium as well. This is one of the historic auditorium of University of Karachi, and a very unfortunate incident happened in University of Karachi, where we lost some of our Chinese teachers and faculty, and we dedicated this auditorium to them. Chinese consulate is actually inaugurating officially this auditorium after the conference. So we are actually here first time after the renovation. So I am very much thankful, and we are actually blessed to have a person who actually leading the university with so much administrative support. I am also very much thankful to Professor Dr. Tipu Sultan, who was one of the person who was actually there to support our 6 days workshop that was happening before this conference. It was international conference, and we had Pakistan representation from all over the countries. We have some participants from Multan, Faisalabad, Narowal, Lahore, Islamabad. So we are hosting them since last 6 days, and they are here to present their work as well. We also have a live session, so we are going live, and there are almost 30 plus global participants who will be presenting their research work in different sessions of the conference. The oral presentation and poster presentation, other than that, we have faculty from NASC, faculty from Lahore Sharif Medical College, Professor Dr. Nasir Azarwan, Head of Neurosurgery from Sharif Medical College, Neuroscience person he is. Professor Dr. Tawfiq Ahmad from NASC is here. Dr. Farhan Iqbal from Bhavli University will be joining us shortly. So whole Pakistan is here to present Professor Dr. Intihab Ulfat. He is a physicist, but I have actually very much interested. I was very much interested to invite him because of his work in neurophysics. So we will be having this lecture on neurophysics. So we are actually opening this session with a great enthusiasm and with the diversity of the talk. Lastly, I would like to thank 2 other people who are much more supportive in the conference and patronage of the conference. One is our Vice President, Professor Dr. Arif Heritage, who not only supported conference financially, but also he actually supported the conference morally, and he was the one person. He was always calling me and asking me that all set, all in control, and I always said, sir, all in control. And the last person, Professor Dr. Ataur Rahman. Professor Dr. Ataur Rahman was very supportive throughout the PASBAN journey, and he was always here. In 1-2 conferences, he was not here, so he actually sent the recorded message. I still remember. And sir was very supportive always to actually not only host these conferences, but also to actually promote the neuroscience in different adventures of Pakistan and the global community. So I thank you all for growing with us, and next year, the decade of neuroscience will be celebrated, and the host will be Professor Dr. Nasir Zaiwan from Lahore. So we all will be going to Lahore. So I'm just announcing it that you all are invited for the 10th Annual Neuroscience Conference, and it will be a decade of celebration for neuroscience. Thank you so much. We are very glad to have you at the University of Karachi.
Ladies and gentlemen, esteemed colleagues and honored guests, it's with great pleasure and immense regret that we gather here today to welcome a truly luminary in the realm of academia, Professor Dr. Halima Rafi. Serving as the Vice Chancellor of the University of Karachi, his distinguished contributions to the field of education and research have not only enriched our knowledge but also have ignited a spark of inspiration in countless individuals worldwide. Let us join together in a heartfelt applause to express our gratitude for his invaluable contributions and to eagerly anticipate the insight he will share with us today. Thank you, Professor Dr. Rafi, for gracing us with your presence and for continuing to guide us on the path of knowledge and discovery. Sir.
Professor Dr. Ataur Rahman Sahab, Current Chief ICCDS, Professor Dr. Athar Inam Sahab, Founder PASBAN, Professor Dr. Tipu Sultan Sahab, Chancellor, Malik University, Professor Dr. Arif, PASBAN member, Professor Dr. Kharat Batul, Chairperson, Department of Biochemistry, Dr. Sayyid Gurulan, Director Audit, faculty members, students, Assalamu alaikum. For me, it is indeed an honor to be part of this event. The event about the 9th International Conference. It's about neurosciences. 6 months back, I was not appreciating neurosciences. I am a very average student of management sciences. And we talk about the management skills. So I was learning about neurosciences, its contribution in terms of human facilitation, solving human problem, coping with the future challenges. What happened since 6 months back? I had a health problem. I had my perennial vein depression. Depression I get perennial vein. So I went to different doctors, and ultimately I got my treatment with narrow disease. So I realized that the pala padta hai na, then you said what miracles neurosciences has done in our life has to be pondered, it has to be investigated, it has to be shared. So I really appreciate the organizer of this particular conference focusing about the neuroscience. You can see I was going through your abstract paper of this conference, very interesting. मैंने सारे पेपर नहीं पढ़े तो टाइटल पढ़े उससे अंदाजा लगा लिया ठीक है टाइटल It's very heartening for the University of Karachi to organize this conference. Why we organize conferences? Why we indulge in debate and discussion? It's about advancing the frontiers of knowledge and research. That's what I believe. Whether it's about social sciences, whether it's about neurosciences, whether you name anything. The purpose is advancing the frontiers, the new knowledge, the new skills, and the research. Research, not for the sake of research, no many fear. But what people are doing is excellent. Ataur Rahman Sahab and other people, they have their contribution. And I must recognize Tipu Sultan Sahab. टीपू सुल्तान साहब से मेरी बहुत कम मुलाकात है, but he has done society. Once you got a position, it's about repay back to your community and society. ये अल्लाह मियां ने आपको पता दिया, आपकी काबिलियत पे नहीं दी, मैं तो समझता हूँ मेरी काबिलियत पे नहीं, मुझे इसलिए दिया है कि मुझे सोसाइटी को सर्व करें, that's the spirit for it. And I see such a spirit टीपू सुल्तान साहब. मेरी टीपू सुल्तान साहब से पहले जब वैसे जानता था, पहली मुलाकात इस सिलेक्शन बोर्ड में हुई और टीपू सुल्तान साहब से लड़ाई हुई. Now, once I became the vice chancellor, I realized Tipu Sultan was right. It's never too late. It's never too late. Definitely. So let's talk about the conference. I must appreciate the people who have organized this conference. And I see a lot of students, and I'm more interested in students. They are my product. And I need to develop the skills which is required in the market. If I fail to develop the skills which is required in the market, then I'm not potential. You have the potential, you have the guts. But the people who got the responsibility, I have a big question on it. The teachers community, how we have fulfilled our responsibility. कभी सोचे इस दफा मुझे नहीं करने चाहिए, but this program is being organized by the Department of Biochemistry in collaboration with the organization. I fail to see effective members of biochemistry. I fail to see good. तो जो सियासी लोग हैं मुझे नजर नहीं, right? So whenever the student, I tend to attend conferences, खासतौर पे बाहर के जो conferences होते थे ना, मैं मादर के साथ इसलिए जाता था कि मुझे नाश्ता भी मिल जाता. Those people who travel abroad, ठीक है, सुबह को जो नाश्ता है conferences के अंदर तो free lunch, free breakfast, और वैसे इतने होते नहीं हमारे पास कि लंदन में बैठ के कहीं और बैठ के कोई तैयारी कर सके, तो conference वाला opportunity, ठीक है. But I used to attend conferences with the thinking that I am going to reach some consensus, some order, some conclusion. But let me share, it creates more confusion and more disorder. That's good, that's positive. There is nothing wrong with it. If you have orthodoxy approach, you will go for order. If you have heterodoxy approach, you will go for different perspective. And the word is about different perspective. The word is not about order. Once you have a different perspective, you may have a better understanding. And that understanding will solve human problems. Being a student of public policy, I believe Allah ne ek chीज permanent दी है, बैठ के लो. That permanent is about problems. Problems are permanent. Once you have solved a problem, it is going to be replaced by another problem. So, one thing is permanent, that is called the problem. What is the way forward? The way forward is solution. Solution based on knowledge and fact, not based on emotion, not based on theory and fakiri. I live in a society. जब डॉक्टर कहता है कि भैया ये कर लो, 2 दिन के बाद पीर फकीर के पास जाए, तो मैं शुगर हो गया. 20 साल पहले मुझे याद है कि लोग हैदराबाद जाते थे इलाज करने के लिए, और शुगर के इलाज शुगर ही करते. So those people who are in the field of science, यदि दुनिया ऐसे नहीं करती. The world is about rationality. रैशनैलिटी कब आएगी जब आप रिसर्च बेस्ड काम करेंगे, जब आप फैक्ट्स के ऊपर बात करेंगे। एंड पढ़े लिखो लोगों का काम यही है, रीडिंग वाले में और आप में फर्क होना चाहिए, ठीक है। वो भी अच्छी बात बोलता है, मुझसे तो शायद अच्छी बात बोलता हूँ, पर मेरे पास कागज है अपनी बात को साबित करने की, उसके पास वो कागज नहीं है। So I don't want to take much time because मैं जहाँ जाता हूँ वाइफ कहती है कि तुम अपने आप को इंप्रेस करना चाहते हो, she's got jealousy with me. Thank you, ladies and gentlemen.
Thank you so much, sir. Moving on, I would like to welcome Professor Dr. Ataur Rahman, UNESCO Science Laureate, Professor Emeritus, International Center of Chemical and Biological Sciences, Karachi. Sir is one of the most eminent researchers of our time and time to come. He is a true pride of Pakistan with countless contributions in the field of chemical and biological research. Sir,
Ma'am,
no, I think I just take it for Mr.
ठीक।
And my colleagues at the table, ladies and gentlemen, we are students of Karachi. What a pleasure it is to be here, and congratulations, Dr. Sadam, for all the hard work that you've been doing. And also up and down for the kind support to this conference. Keep up the great work. I'm always there and country with whatever way I can. अभी मैं बैठा हुआ था और सोच रहा था कि आज से कोई 62 साल पहले 52 years ago, I walked as a student to this hall, sat somewhere there and listened to a speech of the late Dr. who made so much contributions for the development of this university. So how is it that I can remember? Where are memories stored? What is the chemistry of thought? The molecular basis of memory. So the process, you're going to have about 100 billion neurons. So other neurons say, after about it, और हर न्यूरॉन जो है वो 8,000 या 10,000 दूसरे न्यूरॉन से गुफ्तगू कर रहा है। So 100 billion neurons, each talking to 10,000 other neurons. Arguably, this is the most complex object of our universe, our own brain. इतना कुछ साइंस में तरक्की के बावजूद हम इतना कम जानते हैं अपने दिमाग के बारे में। अभी मैं डॉक्टर आपसे यही बात कर रहा था कि there is so little that we know about. We know where memories are stored. We know what different parts of the brain, how पे मुख्तलिफ functions control होते हैं. लेकिन at the molecular level, what is going on, there is very little known. So about 20 years ago, we started thinking about it, and then I proposed a theory at that time, which was published in a major international journal, the molecular basis of thought. And that was basically, कि जो आपके दिमाग के अंदर जो हाइपोथैलेमस होता है, एक खास हिस्सा होता है दिमाग का, उसके अंदर ग्लाइकोप्रोटीन्स होती हैं। What are glycoproteins? बहुत सारे लोग केमिस्ट्री की ताकत नहीं रखते, तो what are glycoproteins? There is a protein backbone with lots of sugars attached. Glucose, arabinose, fructose, xylose. और ये शुगर की क्या खासियत है कि बहुत सारे हाइड्रोक्सिल ग्रुप्स होते हैं इसके अंदर। तो एक अल्लाह ताला ने एक किस्म की मखमल बना रखी है आपके हाइपोथैलेमस के जो ग्लाइकोप्रोटीन्स हैं। And I propose that the process of learning is जिसके अंदर ये मखमल के अंदर हाइड्रोजन बॉन्डिंग हो जाती है उन ग्लाइकोप्रोटीन्स के हाइड्रोक्सिल ग्रुप्स में, and you have partly folded proteins being formed, patterns बन जाते हैं। So the process of learning is the formation of these partly folded glycoproteins,
And the process of forgetting is the breakage of these hydrogen bonds, जिसमें ये patterns disturb हो जाते हैं. This is just a theory. आज 20 साल बाद भी जो functional MRI है, that's the technique where you're looking at magnetically you're looking at the hydroxyl groups, especially the protons present. So we cannot prove whether this theory is right or wrong. But there is growing evidence that I may have been right. And that has taken us into the whole area of neurodegenerative diseases, जैसे मिर्गी है, epilepsy है, उसके अंदर और एक local medicine plant है, Delphinium denudata और दूसरी plants है, Comiton की species. तो हमारे laboratory के अंदर डॉक्टर सोनिया यहाँ बैठी है, प्लांट किया है हमारे. तो एक प्लांट मशीन की है जिसमें हम इंडिविजुअल आयंस को एक्साइट करते हैं with very deep currents of 10 to the minus 12 of an ampere. और फिर देखते हैं and we can artificially simulate epileptic-like behavior in neurons. And then we can see the suppression of brain-derived neurofactor and other subfactors using these extracts or compounds. I'm just trying to very simplify 20 years work in about 5 or 6 minutes. And as a result of that, we discovered some very exciting compounds, isoxyritone, and these were internationally patented. They are potent anti-leptic compounds. And then we synthesize libraries of these compounds, etc. And they are very strong anti-leptic activity. And that has taken us into the area of Alzheimer's and Parkinson's, and we have set up animal models to look at these neurodegenerative diseases. So this is a very exciting area of science. The chemistry of our own brain. How does it function? How do you learn? How do you forget? How do you store knowledge? So, according to us, it is these patterns when you are, for instance, I look at my watch and immediately hydrogen bonding is a very fast and reversible process. DNA would not exist as a double helix if it was not for hydrogen bonding, because they are strongly bonded to each other because of the multiple bonds. Water would not be water if it was not for hydrogen bonding. It would exist as vapor, and so on. So it's a fundamental process. So there is growing evidence. It's not true that we are right, but that's what science is all about. It's and even this morning I've written an article on it. And then we come to the area of consciousness. Consciousness kya hai? What is the molecular basis of consciousness? And that is actually related to this. So we talked about the logic. What is logic? So what we proposed was that these patterns they then interact. And a paper that I sent for publication, which has been accepted just 3 weeks ago, is based on what is the process the patterns may interact. And there are various ways in which they can interact together. And then logic becomes the overlay of these patterns. The ability and emotions then also are related to these very patterns. So it's a very, very exciting area of science. The holy grail of science today is the understanding of our own brain, how it functions and so on. And this leads us on to areas like what is consciousness. And Roger Penrose, who is the Nobel laureate, he proposed quantum basis of consciousness, and some of his papers are very interesting. Kendall, another Nobel laureate, has done a lot of pioneering work in this field as well, and there's a lot of other work that's going on that I cannot describe. But then we are also to realize that we are in the middle of a huge new revolution and we hardly know it. The whole civilization is going to change in the next few years. It's already beginning to change today. And that is because of two facts. One is related to hardware and the other is related to software. Hardware, quantum computing is coming in, and already there are quantum computers around which are hundreds of millions of times faster than your fastest supercomputer. And there is a huge opportunity for personalized medicine, individual drug development, etc., due to the development of quantum computing hardware. On the software side, you see artificial intelligence coming up, And there are many tools already available, ChatGPT वगैरह तो आपने देखा होगा और इस्तेमाल किया होगा, लेकिन there are many other tools which are available. Conference reference को organize करने के लिए मैंने और बहुत सारे और tools आ गए हैं. So these two are going to be, and they are beginning to be hardware, quantum computing, and software, artificial intelligence. And when they meet and blend with each other, which is beginning to happen, everything around us will change. So today, you can't imagine there will be no judges, there will be no lawyers, there will be no teachers, everything is now personalized computers are available. आप खान अकेडमी में जाए, खान मी को एक पर्सनलाइज्ड ट्यूटर खान अकेडमी ऑफर करता है, which is tailored to individual student needs. क्योंकि हर एक कोई अलग तरीके से अलग रखता है. इस तरह और एक हार्वर्ड आप कहीं जाके आप रजिस्टर करें अपने आप को, तो हार्वर्ड यूनिवर्सिटी के कोर्सेज हैं, उसमें भी और कुछ फ्री कोर्सेज हैं, तो पर्सनलाइज्ड ट्यूटर्स आर ऑलरेडी अवेलेबल टुडे. And so on, whether it's nursing, whether it's health, and so on. So we are in the middle of this huge change. So these are exciting times. These are exciting days, and this is one of the most exciting fields of science. And I'm glad that Dr. Sadat, you are also now having conferences on artificial intelligence, which is very related, very closely related to this. Lastly, with this artificial intelligence and the kind of consciousness that will develop through artificial intelligence, which is already happening actually, when in the state of singularity develop. Singularity is when computers become self-conscious. Computers develop a personality. Computers have emotions of sadness and feelings and anger and happiness. That is also going to happen. And it is predicted that within 10 or 15 years' time, this will happen. And then the blending of artificial intelligence with natural intelligence. That's another frontier which is happening right now. Elon Musk, जो टेस्ला जिन्होंने गाड़ियां बनाई थी, उन्होंने एक कंपनी बनाई है 10 साल पहले जिसका नाम है Neuralink. और Neuralink is dedicated to having computer chips implanted into the human brain to be able to tackle various neurodegenerative diseases, and that is the beginning of another horizon. The blending of natural and human intelligence. So exciting times. Congratulations, everybody. Keep up the great work. Thank you, Stan.
Thank you so much, sir. Moving on, I would like to welcome for the plenary talk, Professor Dr. Syed Attar, Professor of Neurosurgery, Scientific Director, Juma Research at Afghan University Hospital, founding President of PASBAN. Sir, please. Assalamualaikum and good morning. Professor Tawar, Professor Raki, Professor Kita, so, and you know, Dr. Professor Sonia, Professor Professor yeah, very good. Professor and Professor so, you know, thank you very much, all of us. So, this is very exciting, and thank you very much for the warm welcome, Dr. Rahman, the eminent scientist of Pakistan. We are lucky to be living in the era. You don't even see him. That's a wonderful thing. So, and thank you for giving the speech that I was supposed to give. So now I'm thinking about maybe changing the topic now and talking about something else. Actually. So, you know, it will be difficult task to actually follow up on that one. Professor Talik, but again, is there a way that we can put on the lights better? Light off. Light off. So, this is the 9th Annual Neuroscience Conference, and Dr. Tata is the main person who actually has been pushing this thing. And really, when I'm done with the demo, so we all should thank Dr. Tata for that, because she and her team, include Dr. Shamboon and all the people. The country was formed in 2007, also Professor Raj Chaudhary, Professor Kasim, they were all members of this committee. So, Professor Karim Partner, लेकिन वो काफी से तक स्टेट गवर्नमेंट एक दिन जगह डॉक्टर सदर डॉक्टर सदर को पता नहीं क्या हुआ तो वो टारगेट करना है and that was 9 years ago. अब ये हमारा था हमारे तारा चला गया and Professor Raza Awan is going to take it out of Karachi into Punjab और खबरदार है कि पंजाब नहीं जाऊंगी So this idea about the consciousness is something that is every close to everybody's mind to about what is this consciousness.
Slightly.
So, sorry. So let me introduce you a couple of details now. I'm just a moment, and this is Pakistan Society of Neuroscience. IBRO is involved in it. Neuroscience interest group, that's a group of students in AKU, and we are trying to expand, and we need students from all over, not just having medical school, can industry of Karachi and everywhere join this group. And जो young blood में जो energy है और जो ज़हानत आप लोगों में है वो हम लोगों में नहीं है सिवाय तो रहमान को So you guys have to carry this forward to join the group and get involved in the activity. So we talk about the consciousness over here, some disclosures at the university. I'm presenting it's some of my own information data, little bit from the internet and things like that. And I'm not getting any money fees, right? I'm not getting any data, right? So that is financial disclosure. So I'm writing a book on the story of the evolution of human brain. It's मेरा ख्याल है 1.5 साल में हो जाएगी. It's the 3rd year खत्म होने वाला है, खत्म नहीं है. Because we are almost close to done. So what I'm talking about consciousness is one of the chapters in that book. There are 17 chapters in there. So I will talk about how from mouse to human, from जानते हैं छोटा सा brain और बड़ा होते हुए this is what that. But then the question is, ये जो बच्चा है 24 years, 24 days, 24 hours old. Is this बच्चा conscious or not? 24 hours. What about this gentleman who's in ICU bed? Totally comatose. Is that conscious or not? What about this dog? Can someone go onto that the 3 dots at the right? It says, the floating darling, you disappear. Yes, there you go. Thank you. Old dog, new fresh. So don't underestimate our old people, okay? So this is dog conscious. Then if this is conscious, okay. So is this this is snake, is this conscious? Is C. elegans, this is what research करते हैं. These are neuron that here 2 neurons. Is this conscious? Honeybee, is it conscious? Our autonomic nervous system, not the brain is conscious, but autonomic nervous system, that has about 600 million neurons. More than a rat. Rat has about 100 million neurons. Octopus has about 500 million neurons. There's more than that. Is that conscious? Our entire nervous system, right? And then these smartphones, they collect data from all around and they manipulate you. आपको पूरी तरह control किया जाता है. Are they conscious? By the way, 24 घंटे से कम का बच्चा है next week. So that's one of the first pictures that I ever had. And I was very careful about, knowing myself. I've been doing a pretty question embarrassment. So when I was doing my PhD, I was with Professor Gunter Alta. He is an artist,
he showed this picture on the big screen, and that just blew my mind. You know, it treated dish is the gold particles in, and then a cell divides, it can be fibroblasts, can be vidas or whatever, right? They divide, and once they divide, each one goes separately. But look at it, they are all mirror images, as if it's predetermined. Are they communicating with each other? Are they conscious? This predeterminism was amazing, I thought. And that told me a lot of things that go on in the biology is predetermined. And we can confuse that thing with things like consciousness. So in about 2012, this is Francis Crick, and Francis Crick, everybody knows about that DNA structure, right? But Francis Crick is rather than he trying to break the code of consciousness, and he was not really successful. And it's a very difficult thing compared to breaking the code of DNA. So the Francis Crick Memorial Conference, Stephen Hawking and all those people were there also. They met together and they passed it's called Cambridge University Conference, and they came up with a statement that said that actually the consciousness goes beyond human beings and it goes into animals, mammals, and some birds and octopus. Great. So it was needed, that kind of statement. But I think that was a very myopic statement by these great scientists of the world. Why would you say that an octopus is conscious and say a slug is not conscious, right? And why would you say a slug is conscious, then you say that something like a jellyfish is not conscious? So where did it stop? Where did it stop? So I think they take to understand that. I'm sorry about that. But this was a good conference, or the big statement that really give a good gist of consciousness. So thinking about brain, in about 2050 years ago, this gentleman, he believed that the brain purpose is to cool blood. That's it, right? Because whenever you have an emotion, you have to put it, right? You have to feeling in your. So nobody would think that this is something very good. So it was only Messina who actually thought about these things and put it that this thinking process, which is the beginning of consciousness, beginning of cognition and consciousness is actually in the brain. Started with that. And okay, so the thing is, can consciousness be explained? So there are two views. One is dualist view and one is reductionist view. And I am a romantic reductionist. Okay, I get to hear it. Dualist view that consciousness is a complex phenomenon that is not reducible to matter. I say that's nonsense. Reductionist that consciousness is a biological phenomenon. All biological phenomena should be reducible to material, physical, and chemical problems. I honestly believe in that. I will give my life for that. This is what I absolutely believe. Okay, so the problem is the brain and mind. This division. We all talk about brain, mind. Okay. The person who's really responsible is René Descartes. René Descartes was a great scientist, but he produced this thing into our mindset when the Renaissance was happening. That brain is separate than the mind, and that a lot of pseudoscience in our thought process to separate mind from brain. Whatever we think, whatever our consciousness is, can be explained by physics and chemistry. So, so consciousness is a big thing, right? And it's like these you guys must be aware of this 6 men who were blind, and they said that we want to know how the elephant looks like. And then everybody was feeling the elephant, and this group communication, and they all had different opinion about the elephant.
Yeah.
And so that's the problem, that consciousness, everybody looks at it from their perspective. And there's a very limited view. And this is consciousness. But somebody looks at it from that perspective, they say, oh, this is consciousness. So we have to step back. We have to look at the big picture, what real consciousness is about. So consciousness depends a lot on cognition. And what cognition is basically perception, attention, reasoning. I mean, only somewhat that is cognition, right? And there are levels of cognition. Perception. So even very low invertebrate has perception, right? But then we have memory in there that brings organized knowledge, and then eventually we have come with reasoning, which is based on higher mammals, primates, and human beings. So there are three words that you guys have to understand first of all, and break their relationship. One is consciousness, one is awareness, one is self-awareness. Right? Humans are more. Right. The humans are more than just conscious, they are also self-aware. Scientists differ on the difference between conscious and self-awareness, but there is one common explanation. Consciousness is awareness of one's body and one's mind. Self-awareness is recognition of that consciousness. You can is someone in the world. And I'm not only understanding that one exists, but further understanding that one is aware of one's existence. So, here, this gentleman, Annual Neuroscience, who is an Estonian-born Canadian neuroscientist, he came up with this thing, and which makes sense. There are three kinds of consciousness. One is anoetic. Noetic word stands for knowledge. Anoetic, then one is noetic, and one is autonoetic, right? So anoetic is where, for example, a cockroach, earthworm, they are conscious, but they are not. They don't know, and their consciousness is that they can discern whether it's stimuli, data stimuli coming from their body or from the surrounding. You know, you don't see the earthworm just running around and eating itself, because you know there is some sense of what is outside and what is the body. So that is the anoetic consciousness. Then comes the noetic consciousness, which is a sense of ownership of body and awareness of the agency. To be many can't here. So you know you see things like rats. Rats have this knowledge. They can depress a liver, and they know if I depress a liver, I will get this food from it, right? So that knowledge, that consciousness is called noetic consciousness, knowledge consciousness. And then the last one is the form of consciousness that depends on self-awareness. That's us. Now, but we are not the only one who has that. There are certain dolphins, there are certain higher primates, the great ape gorillas, bonobos, chimpanzees, and there's some birds also, ravens and blue jays, they have this consciousness, and they're tests for this consciousness. For example, if you look in the mirror, we would know that I'm looking at myself in the mirror, right? And if I have somebody put a red dot over here, I will say, oh, this is me that has a red dot. I will look, do this. Most of the animals won't do, but then there are certain birds and certain higher primates who recognize themselves, and that's the self that's in the mirror test. They recognize that that's me. So you know that's the level of autonoetic consciousness that's coming up. So okay, all right. So Robert Hawke, who was working with Francis Crick, and he had spent life on consciousness, and he has done some good work, and he has tried to say where is the consciousness in the brain, and I think they have also missed the concept a little bit. You know, he puts the consciousness basically on the parietal and the temporal lobe. So the brain has all these structures in human brain, the frontal lobe, again, parietal lobe, right, and occipital lobe, and temporal lobe, and there are certain lobes called insula and things like that. Now this part of the brain, parietal lobe, is right next to the sensory cortex outside information value to thalamus. इसके आगे motor cortex से सारी information value to move our body parts. Frontal lobe is basically the prefrontal area that organizes everything. The parietal lobe receives all the information from all the sensory parts, including the occipital cortex, down to vision value, and the part of temporal lobe down to the vision, something like that. And they all put together, and that gives consciousness. So I disagree with that. Consciousness is not in this area. Consciousness is all over the brain, and you have to do the whole bit. And why do I say that? There's a surgeon over there who will attest to that. That you can have patients where you can have a parietal lobe removed, and they will still be conscious. They may have some hemorrhage effect and things like that. And then when we have frontal lobe removed, sometimes we have significant change in personality of those individuals. एक frontal lobe हम बढ़ा देते हैं या तो गाड़ी के एक्सीडेंट में या सर्जरी में, लेकिन अगर दोनों frontal lobe हो जाए तो that patient is totally different. Some of these diagrams are published in Canada. So what happens is that there is a primary sensory area which goes into unimodal association. So information that coming from whatever I'm seeing is going to the association cortex where things are getting analyzed. And then from there, multiple unimodal association area goes to multimodal association area. जहाँ पर मैंने कोई touch की, कोई swingy, कोई देखी, कोई swinging, all that comes together. And that's the multi-modal sensory association area. That is important, that gives cognition. Without that, cognition is impaired. We need multiple sensory input, putting it all together to give cognition. And if you look at it in a rat, so I've been studying the rat brain I didn't see the monkey brain directly, but from the records. If you look at the rat brain, a large area is involved in this unimodal sensory input. This area and this area with the light element, this is where all the information is come together and processed. And that is important for cognition. So there is not much cognition in the rat brain because there is not much of multimodal sensory area. In the macaque, there is some, and they have some cognition. So the cognition goes up, the higher is association area. So association areas of the brain are the key areas for bringing cognition, consciousness out. Now, how does the cognition happen? Weaver and Rico got Nobel Prize in 1981. They were looking at, how really from the retina, all the lines and colors that come from the retina, how do we perceive images? So what they were able to figure out was, but I'm talking about so it's made way, if you look at it, what happens is that there are areas of spots on the brain, ganglion cells that respond to light. And they respond to light, and then they're inhibited by light in the surroundings. So there are areas and off areas in there. So this is an on area, is an off area. So light spot अगर आप डालेंगे retina पे, it will excite the ganglion cell, which will send information to the optic nerve, to the thalamus, and from thalamus to the visual cortex. What happens is that there are these ganglion cells that come together, and they can discern whether it's a line. These spots on and these spots off, and you start to make some sense. In the brain, these spots come together, and a simple cell takes information. So once this neuron, let's say, gets fired, because these three neurons from these ganglion cells are connecting to it, it says, okay, that's a line over there. And from there, if that line, this line like this, if it moves, then these simple cells connect with the compound cells. And I'm showing a very simple picture of here. It tells you that the line is moving. So, it's just the beginning of cognition, if you can understand this point. We are just looking at the lines and colors and contrast and the moving. And then from there, so there's nothing. Now, पीछे कोई पर्दा नहीं लगा हुआ है जहाँ पर तस्वीर आ रही है मेरे पास की डॉक्टर की आपकी पीछे पे ऐसी है it's just that a contrast and all that thing. Those neurons there, they are firing, and in the past I've seen talking and talking and discuss things with them, and they are all firing again. So when talking comes in front of me, so oh, it's talking, right? So it's just a pattern of neurons that fire that tells you what it is. And so, but the thing is that this vision is just a very, very small part of this whole electromagnetic radiation that goes from all the way from very high gamma rays and all the way to the microwave and things like that. I mean, a narrow band, X-rays and also that. And yet we make so much pattern out of this thing. We understand so much things. Can you imagine an animal or anything that takes all the magnetic radiation and builds structure out of it? Actually, there are. So this mantis over here can perceive much more colors than you guys can even think of. We can't think about more colors than what we see, right? So we have never seen it. This one has 4 times more, or 5 times more than what we can see in terms of color perception. Eagle, is such a disguised vision that we can't have that. And then based on that, up in the air and the way they can dive and shoot and grab something, it requires a high level of cognition of those things. But the thing is, they are not that conscious as we are. The reason for that is because we have a special mammalian cortex. That was the innovation by mammals. Now, but that still doesn't tell the whole story. Because if you look at the human brain, we think we have a big brain, excuse me. Elephant has a bigger brain than you, right? And then a cat has a much smaller brain. So if you look at this ladder, we don't have as big a brain. The thing is, the number of neurons over here are even much more. We have about in the cortex, the total number of neurons in our brain are 56 billion. That's the Susanna's research And by the way, the best neuroscientists in the world nowadays are females, so just remember that. Clear power, you have to look into that. So she is the one who actually, for hundreds, for not hundreds, for a few decades, even the Nobel would keep on saying, oh, it's 100 billion neurons and billion neurons. He proved that wrong. He said, no, it's 50 billion neurons, and there's a way of doing that. So, anyway, so the thing is, they have more neurons than us, but they're not more intelligent, not more conscious than us. The reason is because our cortex is defined in a certain way, and we have these micropolar, this circuitry in each one is very defined, and that gives us this extra power of processing. With this constant person, so the consciousness depends on cognition, and then it also depends on memory. So if I think about the memory, think about it for a minute. If I think about your memory, आपने cognition given us might पढ़ा है, यहाँ से ordinance करेंगे. And then after 5 minutes, I ask you क्या था, you don't remember क्या था. So your cognition is affected, your consciousness is affected. The autonomic consciousness depends a lot on the memory. So cognition is one thing, and memory is another thing. Without memory, you don't have the autonomic consciousness. Autonomic consciousness is all about the past experience. You put everything in the reference, and for that, what we have learned is ऐसा करता हूँ मैं ऐसे क्यों नहीं करता हूँ मैं next open out ऐसा क्यों नहीं next okay the connections is important how the brains are connected, that's also an important part. If you look at this picture this actually is not completed yet. So there's a connection between the brains, vertical area, temporal area, and both the area are connected. That also gives this information to the multimodal sensory information processes. Next please. So we learned a lot from Annual Neuroscience. He died. He was, one of the surgeons, like one of us. Became very thought he can remove both the hippocampus because he was having seizures. The seizures did get better, but then he lost his memory completely. And his memory was affected. So we learned a lot about memory by this accident, surgical accident that took place about 50 years ago. So we learned a lot from him about memory. So there are two kinds of memory, explicit and implicit memory. We don't need to go into details about that next week. But what we know is that this memory really is involved in the hippocampus, plays an important part, and then that all the information that we have is more in the parietal area, the cognition, well apart to it, and then the frontal lobe controls this part somewhat. And when what we see in Alzheimer's disease as there's regeneration going on in Alzheimer's disease, we see that atrophy happens and then they lose cognition because the memory is gone, the cognition is gone because all the association areas start to degenerate. Next week. And where does the memory really reside? It's the synapses. The synapses provide the memory. And there are dendritic spines, and there are, as Professor was saying, 1,000 each neuron maybe making connection with 1,000 neurons. And if you look at it over here, this is the cell body culture, this is the dendrite, this is the dendritic spines. And these dendritic spines, they have a lot of potential material satisfaction there. And as their experiments done in like long-term potentiation and things like that, you see that these spines do grow bigger. So it's the strengthening of the synapses that gives the memory. The synapses become strong, and they, that gives the memory. This is my picture when I was in many years ago. So I had grown cultured, in petri dish. This kind of microscopy, and you can see that from this explant, the cells are coming out and they are connecting to each other, making groups over there. And what we see, there's a lot of activity going on in there. That used to just fascinate me. All these are connecting and making connection with each other. There's so much activity. These are all those to eventually connect and make synapses. So it is activity हो रही है next week. It is activity हो रही है. वो जो है इस बच्चे में भी हो रही है. And that's what is happening. So what is this? हम लोग बड़े हो कि मैं किसी बच्चा अपना कौन है? No, the kid is actually exploring itself. So when you are born, you don't know anything about you. And the first thing you do is you start to, you move yourself. oh, what is this? Acha. Acha. So this is my hand, you don't say this is my hand, but you start to know. And then you touch your feet and you touch surrounding and all that thing. So, I recently became grandfather, so I'm re-exploring this thing with my grandchild. So this is what's happening is that all the sensory information is going in there from the unimodal sensory area to the multimodal sensory area, and things are putting together. The touch, the smell, the sound, and everything all coming together, and that's what's happening, and that's so a child when it's born, it has what we call as anoid consciousness. You remember when you were 5 years old or 1 year old, you don't. So that's a anoid consciousness. In few months, you start to develop noetic consciousness. If I touch this, I'll do this. I can pull this, it will come down. That's noetic consciousness. And then when you grow up a little bit 2 or 3 years, then you say, this is me, this is my mom, we are me done, right? That's autonomic consciousness. So we go to the state of anoetic, noetic, and autonomic consciousness. That's what we're seeing here. Sorry. You can have okay, so the problem is that it's not a problem, but that's how this brain works. Although it has at least 6 billion neurons and 1,000 times more synapses, and we get all the information, we filter that information, a lot of that, but then we can't synthesize all the information. There's too much information there out there, even for that narrow band of electromagnetic wave, even for that narrow band of sound waves, too much information. And then not only that, when we filter it, there's a lot of information that we did not even put together, we didn't remember. So we put it all together. So that's where this memory, the fabricated memory comes in. So, if I see this thing, everything is getting registered over there. Every dot is getting registered in my retina. I walk out, I will probably remember 2 places. And then 10 days from now, I will even forget those. So what happens? I start to build up memory. And that's where the problem is. That's what problem happens. But it's very important. It's not a problem. It's a solution. Because your brain cannot store every pixel of information. What you store inside is a concept. And there was all full of young and brilliant people who were talking about neuroscience. Next, please. And that's what happens when we are trying to bring together information and trying to say this is a chair in my library. How do I know it's here, right? Because I'm getting information, I sat on it, I felt it, I touched it, I know where it is present, and the Metrodata, I saw things like that. And my Amijan told me, we could see him because my parents were not mommy, daddy, so Amijan and so no, could see like a mommy, daddy, and go to hey, is chair. So, and then later on, I learned that chair, kursi to chair thing. So, I now have this understanding with the chair, the leg goes and says a bad thing, this all comes together because language, hearing, seeing, sitting, feeling, and maybe, emotional things that happen with this chair. It's all in there because there's a chair from my Northwestern University, and I got a feeling of that. So I look at this chair in a different way than everybody else will do. And that's the expression, that's the quality. So the way I look at the sky is blue, and that experience of consciousness of that thing is different from any one of you. How do you know that the blue that I see is the same blue that you see? There's no way that you can figure that out. Maybe you're seeing it red, but you're calling it blue. Or maybe what I'm calling blue is actually red. So, there's no way that we can communicate, right? That's for me. So that's my personal experience. That's personal experience of personal experience. So all these things that build up consciousness are like that. Next, please. So what happens is here, if you look at this, there are so the first order theory is not really. There's a higher order theory where, let's say, if we say it's a red thing is an apple and this red thing is a ball, or this is a chair, because visual cortex information and prefrontal cortex work with. Actually, the global workspace really works better because there's a lot of information that comes together and pulled upon when you see something new. Now that can be put together. So this is a chair that is present in the library, which was you brought from, not in the university, blah, blah, blah. And so now if you look at this, what does it say? It says ABC, right? Right? I don't know. Next.
13.
13.
13.
So, so whatever is the background that your permission takes, right? Are we telling? Okay. So next week, so actually, it's the same thing, but depends. What is the context? Next week. So looking at this context, essentially, I started to look at this is honeybee that I'm very proud of the scripture that I took. But all these. So look at the sensory information that this honeybee is getting. These are the 2 eyes, but there are 3 eyes over here, silly. All insects have these extra eyes. And then look at this. I mean, do you know that this is a balance kit? You do, right? And you become the balance. हम लोग के बालों को आप लोग कहते हैं कि कितना ये बनाना लग रहा है तो she the connection has a lot of data. So all the information is coming through there. The antenna has a lot of receptors for sending information, orders and things like that. They all that coming together, and that's the consciousness in a noisy consciousness that happens in the next week, that happens in a week. So यहाँ पे जो है diagram बनाइए कि the prefrontal memory, working memory, vision, touch, and audition, 3 months. It's a feedback that goes to and that from the emotions to the cognitive area that gives you this feeling of cognition or consent of the which leads to consciousness. Next. So you see this. I mean, after when you the chant देखते हैं तो आजकल तो जमाना तो मेरी पहचान देखने का क्योंकि it's all so that if they want to say this, we used to actually go out मेरी पहचान देखते थे तो I think also मेरे हाथ बैठ गए डॉक्टर So but then have you noticed we can think of a chant go ahead, you don't see it, right? But we don't see a hole in it. We see it in the सारे इधर वाली है कभी जहाज उड़ रही है जहाज कहाँ गई that's big, right? And then once you start to see it, so what happens is that our brain fills up information. It does not say, oh, यहाँ पर जनाब यारी आप नहीं देख रहे next week यहाँ पर नहीं देख रहे यहाँ black होल है you will see over there. It doesn't look that. What it does fills up information. So that's the problem with the cognition and how the consequence create. You can dive into that next week. So although I disparaged my friend René Descartes, but René Descartes was a man who actually started experimental thing, and then Joseph Priestley and all these people talked about how to do experiments and things rationally as Professor Dollarmont is talking about. Really try to hone that idea in there. Psyche, this, the Aristotle part about psyche, everything life can explain by psyche, nonsense. You can explain a lot of living processes by physics and chemistry. And that's when Joseph Priestley and all the group of scientists start to work on that. And coming to the same honeybee next week, I said, okay, I dissected it out and pulled out its brain. It was a honeybee brain. Now, it's not surface of brain. It's 100 million neurons. And this bee can travel all the distance, come back, find the nectar, bring it back, build a beehive, communicate to everybody else in the beehive. It does all that thing, and that was the brain. So that's a noetic consciousness. So I said to my brother, who is he is an inventor in the university, and he has a lot of patents. His chips are pulled from Taiwan to the USA. So I said, can you beat that? So he came up with this NXT chip. They said, it's very interesting. So actually, it does have, about 5 billion transistors, right? We have 100 million neurons. And mind you, transistor, if you guys know about transistor, there's a 3x. So the NPN junction of PNP junction, right? You know that, right? Whereas a neuron, each synapse has an analogous behavior, each synapse. It's not binary, it's not 0, 1. Each synapse has this analogous processing. और फिर उसके बाद सारी information जमा होगी एटॉमिक रिजॉल्व पे जाती है वहाँ कंफर्ट करने वाला processing होती है. So it's a much more complex. 1 neuron is equal to 5 million transistors in mind, right? Which brings me to the point. And by the way, this is a small chip over here, and this I9 you have code processor. It has many more transistors in there, but then it takes too much energy. This one that we designed, it takes only 0.3 watts. That's what we use. Brain takes a lot of energy. But, and we are not as fast as this one. But then, come on, it's only 700 million neurons compared to this, yes, it's winning. But then time will come next week. Time will come when we will be losing to artificial intelligence. Not at this point, maybe not in the next few decades, but we will. Because it's all about the processing of information. You know, again, zero binary पे जा रहे हैं, 0 1 पे जा रहे हैं, so, you know, the Turing test, you guys know about it, and I'm not talking about it because we are going to behind. But, you know, that's how the artificial intelligence test, coming in, and we will be losing it because Dr. Dharma was saying, you know, they have to behave, they will start to have emotions, and all that. Emotions help here. Next, please. Emotions, you know, I disagree with this gentleman, that I'm not taking for it. He says it's not easy to deal scientifically with these. Wrong. It is easy to, it's not easy, but it is scientific. It's an algorithm, complex algorithm, that's what it is, nothing else. जो आपके इमोशन है ना, आप लोग किसी को देखा और मोहब्बत में आके ऐसे करते हैं, या आपको खाना नहीं मिल रहा और आपको अफसोस आ रहा है, all those things, it's just like a few set of neurons in the amygdala, nucleus and all those, they are behaving, and if I can accumulate them, I can change the behavior, and we do that with the stimulation. So it's not something magic, and you know, our friend encouraged me. This now the algorithm on that. He said that long time ago, it's all algorithms, and our brain is all algorithms. Next, please. So, you know, if you want to believe and think, there are people who say, you know, some Zambala, a kashmir to put to the dunya, or Kashmir Pinta, or Zambala. And I have talked to a gentleman, a physician, a doctor, who said the earth is flat. And there's a flat earth society also. So there are people who will talk about these things. And you know, with due respect to you know, I don't believe quantum is the basis of the consciousness. And there are people who say the stone has all that nonsense. Next, please. You know, we treat brain like a black ball. We think that we can change it. So I can speak very loud. So we think about these things that, you know, our brain has so much power, but that's all pseudoscience. You know, we need to stop that. We need to think rationally. We need to think rationally. Whatever we can experiment rationally, we do that. Whatever we cannot experiment rationally, you know, we just say, okay, we will figure that out. But don't accept that over time. And I have a slide of taken over here that extraordinary claim needs extraordinary evidence. He talks about you know, solutions that, for example, somebody says I saw Mary, you know, but then what is the claim? Just because you saw Mary doesn't mean that no, it's true. We have evidence for that. So whenever the claim is extraordinary, you have to give a lot of evidence. And that's our basis of scientific understanding of science. The next please going on. Is it gonna turn on? Almost done.
जब आपको बोलना चाहिए था let there be light.
Let there be light. So that's the first chapter of my book. You know, let there be light. We talk about how the so anyway, so recapitulating the idea of consciousness is that by the way, you know what, the light is, you know, so don't fret on it, enjoy it. It is part of us, right? It never happens in Vienna, it never happens in San Francisco, it happens in Karachi. But it's part of us. Enjoy it. You know, don't think the river down. We're living the life is full of unexpected things that happen. So the idea about consciousness I want to talk about is that if you think in these terms, that basically there's a unity consciousness, noetic consciousness, and then the idea that it's the sensory stimuli that comes together that gives you cognition. And the cognition, say, after automatic consciousness done here. If the sensory stimuli are not that, processed in a complex way, you still get some consciousness, such as a cockroach, earthworm, right? And, my body is, plants don't have consciousness, and rocks don't have consciousness. They have biological phenomena. So, a plasmodium or an amoeba will respond to stimuli. If it will respond to stimuli, it will move towards where it sees food. Is the bacteria conscious? Not really. So the consciousness requires a nervous system. And the autonomic consciousness, as we talk about consciousness, that requires a lot of processing through these association areas. Look at them in great groups, bonobos and chimpanzees, they are there, but not to that extent. Next week, starting, I think I'm almost done. Can you move to that? Finish the bad hair. Yeah. So this is I have to point this thing, and I think this is one of man who actually was instrumental in making popular science. Is that what counts is not what sounds plausible, not what you would like to believe, not what one or two witnesses claim, but only what is supported by hard evidence, rigorously and skeptically examined. Extraordinary claim requires extraordinary evidence. This is just not the scientific thing. Next thing. And you all have heard about this magic carpet, right? Go ahead and believe in it. It's beautiful. Enjoy it. But then it's the science and technology that push this mega tons of matter from here to San Francisco, and you're sitting in it. I've never ever seen a magic carpet. Have you ever seen that? No. But so legal magic carpet for story sets. So but don't mix them together. That reality, that's science and technology. And that is, stories and fantasy, which is good. Don't get rid of that, because life and other things are just story fantasies. But then distinguish, leave those logos, people distinguish them. And that's it. Thank you very much.
We'll be taking 2 quick questions for Q&A session. So if anybody has any questions, so we can take them. Please keep the questions brief. Sir. Can you have the mic for please?
I will wait for Dr. Atif to settle down. I don't want him to fall down after hearing my question. It's not a question, it's more of a comment. And it's not a comment, and it's not a quick one. So I'll need to take a couple of minutes.
Sure, sir.
First thing is, whatever Dr. Atif told you about consciousness is one aspect of it. I'm not saying it's wrong, I'm not saying it's right, but that's just one way of looking at it. There are 100 other ways of looking at things, and none of them has yet been proven to be right. So when you have so many ways to look at things, that inherently means that you don't understand that thing very well. So outright dismissal of the dualistic concept, I would not really agree with. I believe we don't have evidence for it yet. We don't have the science for it yet. Maybe, yes, later on, sometimes we do have science for it. Maybe even quantum physics sometimes does come up with things, with things and theories that can prove the existence of something separate other than matter, which can explain consciousness. And that does not mean that we should dismiss it outright. I love Carl Sagan. I do not disagree with what he says. He's a hardcore scientist. But one of my own, people that I follow and who actually led me towards science when we were in school and college. But again, with Carl Sagan, I would disagree with the fact that whatever has documented evidence, that's the only reality. Every theory, every reality, every new concept crashes, breaks the previous one. Newtonian physics ruled for hundreds of years, but then relativity overturned it. For those 100 years, it was solid reality. It's not anymore. So I would not believe that hardcore science is the only proof that we have. Science progresses because it is followable.
Absolutely.
If it was not followable, it would not progress.
That's the beauty of science.
That's the beauty of
The beauty of
science.
science is that it's always humble. It says, get me more evidence, I will prove.
True.
That's the only set of knowledge in this world that is so humble. The problem is, if you start to go into these areas, so there's no stopping.
True.
So, I mean, I just want to say is rain is cools the air. They say cycle is required, but then you need to define, I'm gonna do some experiment and try to figure it out.
True.
So, I'm not dismissing that there's no magic carpet.
Then
I'm not dismissing that.
I rest my case.
I'm not dismissing that. But show me magic carpet.
True, but you
So,
have,
so that's the problem. You have to see things before you say, okay, I'm gonna move in this direction. Because in the unknown, there are zillions of possibilities. How am I gonna pick one possibility, which is, this is the truth, right? So you need evidence. But then as a good scientist, that's what you're saying, as a good scientist, don't say no.
Yeah.
So I have not said no to anybody. What I have said is for me to experiment, and that's what Carl Sagan said. So magic carpet, I showed the picture there, but I have to see it some flying in the air. Huh?
Yes.
If they show it to me, I'll believe it. I have to see that the earth is roughly flat. I'll believe it. So the problem with this approach is that we start to go to pseudoscience. And that's where, you start to believe things and, then it goes away from the mainstream science. So for hardcore mainstream science, the good scientists will do that, but they keep the mind open. Anything can come from any point. That's the way.
I really hope, President, when I'm presenting my talk on reality, because
I can add to it. It's not about seeing, it's not about believing. I'm going to reach my destination. True.
Where the evidence here would do.
Yeah.
In that point, but.
Just want to make a little point here. No, I don't. Sorry.
I know you don't, sir.
Okay, thank you. Take a point, move it, you get a line.
Right.
Take a line, move it, you get a plane. Take a plane, move it, you get a cube or a three-dimensional object. Take that and move it, what do you get? Your mind stops. So we are features trapped in a certain dimension. And the truth is far bigger. So both of you are right in your own ways, but we need to understand our limitations.
Yes.
Would like to share his view. So please.
After hearing all these super duper thoughts about the consciousness and the phenomena, being an physiologist in my profession, I'm a study school to learn what study of then I get with the astrology, मैं सोच रहा था कि अब मैं very interesting and especially by eminent speaker of Suriname, very fascinating, and there are a lot of information which I got today, and good old saying that every day is a learning day. So it is a learning day for me today. Thank you.
I would like to invite Dr. Uday, the director of Audit, to share her views.
Bismillahirrahmanirrahim. Honorable Vice Chancellor, the fountainhead of leadership and the neurosciences, distinguished guests, faculty members, and students, assalamu alaikum. I'm glad that you are still in an energetic mood. Usually होता ये है कि जब sessions खत्म हो रहे होते हैं तो हमारा energy level down हो जाता है. So the entire credit goes to the perspicacious, insightful, and sagacious discussions that have been
Excuse me.
occurring over here since morning. So all of you are conscious. So I'm here to share the vision, the academic vision of the university. Before starting my talk, I would like to thank Professor Dr. Farhad Batul for inviting me here to share my views. As we all know, we are living in a rapidly changing world, where new challenges and opportunities arise every day. That's a common thing. But we need to be prepared to deal with those challenges as a lifelong learners. So in that particular context, we need to be conscious. Abhi, Dr. Taraman said very अच्छी बात की. We have billions of neurons in our brains. Similarly, Dr. Athar said the same thing. But unfortunately, what is happening? We do not coordinate, we the people. So today I'm going to link the vision with neurosciences. I am not from the field of neurosciences, but as a layman, I know that the neuroscience is the scientific study of nervous system, the brain, spinal cord, and peripheral nervous system dysfunction and disorders. If it fails, everything fails. Is it right or wrong? So if I connect the academic vision with 3 pillars of neurosciences, I say the academic vision should be based on the ethos of quality, diversity, and impact. Quality means ensuring that programs, courses, and researches are of the highest standard in relevance. Diversity means embracing the richness of perspectives, backgrounds, and experiences that our students, faculty, and staff bring to our community. And impact means translating our knowledge and skills into meaningful actions that benefit society and the environment. We have to reconnect to the society, and we have to deliver to the community. To achieve this vision, we have to look at the content and the context. So now the question arises, what is the current context? The current context of the world entails global health crisis. COVID pandemic has triggered various neurological disorders. Besides, we are going through socio-political, economic meltdown. What we can do as people of academics to make a difference? Because it is a hard time to navigate crisis into opportunity by focusing on for the sustainable development of our people and planet. We need to be the leaders who can inspire others to pursue excellence and innovation, and truly speaking, we are. The neuroscience people are my ambassadors today, because being the director ORIC, I feel it is the right platform to address the paradoxical incertitude and the conundrum of strategic perceived value of directorate of ORIC in the global and Pakistan's academic environment. In Pakistan, the enigmatic perceived image of auric function vandalizes its strategic status with a significant magnitude and hurls it at the risk of irrelevancy. And unfortunately, it is happening at the University of Karachi. If I look at the HEC ranking of auric, so hum niche se top kar rahe hain. And we are having the living legends with us. So what is happening? Where do we lack? We don't do dialogue. Our neurons are actually not connected. So it is actually a high time to have collaborations, dialogue. I'll be coming to you people right now. I am working on the auric policy under the supervision and able guidance of the Vice Chancellor or Honorable Vice Chancellor, Professor Dr. Khalid Mahmood Iraqi, who is actually my supervisor, PhD supervisor. He's my mentor. He is the one who developed me. I am his product. I studied from him when I was an undergrad, and I earned my PhD degree under his supervision. So I am happy to return to my second home. So I need your support, and this is the first platform from where I am sharing a few pieces of the vision that I have. And I said 3 things. What were those? Neuroscience people. You were conscious at that particular time. What was the first one? Quality. Yes. Do we have a quality? How many will say yes? We are reducing quality. Okay. We have diversity, and now it's the time to create an impact. So we have been listening to the slogan, publish or perish. I am coming with a new slogan. Let's innovate to regenerate. And come to us, commercialize your researches, get a patent, and serve the community for sustainable development. Thank you so much. Because ideation without execution is nothing more than a delusion. Thank you. Thank you so much.
We'll be moving on to solid distribution now. I would like to invite our VC, Dr. Iraqi Saab, please. Sir Tipu Sultan, please kindly receive your souvenir here from Dr. Iraqi Saab.
Excuse
Sir,
me.
kindly receive your souvenir here. Sir, please stay on the stage so that the souvenir can be passed to the other members as well. Dr. Tipu Sultan, kindly pass on the souvenir to VC or Professor Dr. Khalid Mahmood Iraqi as well. Next, we have Professor Dr. Syed Azhar Imam. Kindly, sir, receive your. Professor Dr. Ataur Rahman, kindly, sir, receive your souvenir. Professor Dr. Duyola.
Let me correct you here. I'm not professor. Thank you, sir.
Some people are born professors.
It's really an honor to have this kind of.
Because, thank you, Dr. Gulman. Now we have some sheets for the speakers because all of them are here. We have sheet for Professor Dr. Nasir Azarwan. Professor Dr. Dawki Ahmad. Professor Dr. Intihab Ulfar.
You know, I'm very conscious of female activity. You know, it's too much. I didn't mean to say
So we will have the next sheet for Professor Dr. Farhad Batul for. Professor Dr. Intihab Ulfar. Professor Dr. Farhad Batul. Dr. Jonas Budi. Professor Dr. Shamim Qureshi. Professor Dr. Farah Iqbal. All of them actually contributing to the executive session, so these are a big round of applause for it. We had a message from the director that fasted, but unfortunately he couldn't be here. So we have a presentation of fasted from the substitute. Please receive the sheet for Professor Dr. Akram Sheikh, Director General Council. Professor Dr. Sana Akbar. Professor Dr. Farhan Iqbal. Dr. Farhan just arrived from the Department of Biochemistry. He joined us from the station actually, and he's just coming forward. Dr. Father is from Annual Neuroscience Conference to the concept evolution of brain. One of the prominent member of the organizing team, Vice President Professor Dr. R. Heritage. Professor Dr. Balabasi. Sir will be chairing the session for the posters. Dr. Faizan Mirza. Dr. Shabur Nashar. And last, the order there is. Everyone, and have this announcement.
Good evening, I have a honor. So, being home, I want to impress people. There are not the people who are sitting here, those who are not here. I will share a group photo, everyone stand up, share a group photo, so that I can share what I have done today. I-
आज सब आ गए आज डॉक्टर फाजिल साहब आ गए टीपू सुल्तान साहब आ गए सर आप इधर आते सर आज इधर 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 सर इधर
Sir, आगे आगे
सर
फाइन
कोई मसला नहीं है। ये बंद कर दो, मैंने बंद करा, ये लगा देना।
ये फोटोग्राफर को एडवाइस देना चाहिए आप लोग इधर बैठ जाओ।
अच्छा बेटा, सबको आना चाहिए। अगर ये आप कट रहा होगा तो आप बताइएगा, हम हो जाए। ठीक है, प्रोजेक्टर बंद कर दें।
Good. You did an excellent work. Good job. Yeah. Thank you, sir.
1 minute.
एक मिनट Thank you, Ji.
Thank
God
you,
bless you,
sir.
everyone. Thank you. I am a human being, you know, I got the same thing you got. It's such a putra.
Precious moment. अभी यही रखो। Okay, the online poster session will start in 5 minutes. I request all the online presenter to be available online. Okay, we are going to start the online poster session. We have with us Dr. Zafar Iqbal Abbasi as the chair for the session, and our first presenter. I would request the presenter to be online. Dice. Our first presenter is Dr. Atif Raza Chima. He will be presenting his work on protective and nootropic effect of nutracuticle. Dr. Atif, you have 3 minutes.
Bismillahirrahmanirrahim. My name is Dr. Atif, and I will present about the nootropic and neuroprotective effects of nutraceuticals, their relationship with neurotransmitters, dopamine and serotonin. Nutraceutical is basically a combination of nutrition plus pharmaceutical, and nootropic means cognitive enhancer. So we have about 6 top of the line neuroprotective or nootropic agents. First one is thymokinone Nigeria saiba, which is active ingredient of vaccine. Second one is curcumin, which is present in curcuma lamba. And third one is Pecopa, Maniru, Brahmi Bhuti, and so on. So these neuroprotective agents, what actually they do, first of all, the neuroscience market is growing with a feature of compound annual growth of 3.9%. So neurodegeneration is there in Alzheimer's disease, Parkinson's disease, and dementia, and many other. These neuroprotective agents, they provide useful effects for the degeneration. First one is resveratrol. It is present in red wine. People use it to have neuroprotective effect. Then in China, ginkgo biloba contains ginkgoside and it has passed phase 4 clinical trials, and people are using it to enhance memory and for neurodegeneration in Alzheimer's, Parkinson's disease, and dementia.
1 minute is left. 1 minute is left.
And here in Pakistan and India, in Pakistan we have black tea. In India we have Brahmi Bhuti. Brahmi Bhuti are bacoside. It contains bacoside, which reduce amyloid beta aggregation. It increases intellectual capability. It enhances memory. So take home message is that we have to use daily black seed, okay, red grapes, Calciuma longa, so that we may have neuroprotective effects and nootropic effect. And on the other hand, we are going towards patents for thymokin. I did my research work in the neuroprotective effects and nootropic memory enhancing effects of thymokin. It modulates neurotransmitter serotonin, dopamine positively and protects the neurons from degeneration. Thank you.
Thank you, Dr. Atif. Our next presenter is Abdul Rahman. Our next presenter is Abdul Rahman Bello. He will be presenting his work on approach to reduce social stigma toward mental illness and mental health. Abdul Rahman, are you online? Abdul Rahman is not with us, sir. Sir, you can kindly evaluate it on its own.
No problem.
Should I move to this next?
Oh, yes.
Okay.
See the letter.
Our next presenter is Dasi. Dasi, if you are online, you can unmute yourself and start your presentation. Due to time difference, I guess we are having connectivity issue and many of the participants are not available here. We will be moving on to our next poster. Next presenter is Atoki. Atoki, if you are online, you can unmute yourself and okay, Adasi is here. Adasi, I am sharing your poster and you can then unmute yourself. Please be available online. Yes, Adasi, unmute yourself. Adasi, we cannot hear you. Adasi Maxwell. Okay, thank you. We are moving to our next presentation. Our next presentation is by Atoki. Atoki, if you are online, you can unmute yourself and start your presentation.
Yeah, good morning from this end. I'm very much present online. My name is Atoki. Can you hear me? Hello? I believe you can hear me clearly. I'm online. Hello? Atoki is online.
Yes, Atoki was
Atoki
here,
is
not
online.
coming online. Okay, let me do it in this way that we evaluated on our own and then announce the result in the end. Okay,
Hello,
we will just
Atoki is
show it
online.
on the screen for the YouTube audience and the live stream audience. Okay. Okay. We have
Hello.
our next poster by Glady.
Hello, Atoki is online. I'm online.
Okay. This is a poster on healthcare access of maternal mental health.
I said Atoki is online.
Mental health care problem in formal and informal setting in southwestern Uganda. Life experience of patient and caregiver.
Hello.
Our next poster is by Anam Anjum.
And I am a postdoctoral student at present in the neurobiology laboratories in Poland. I am going to discuss part of my PhD thesis or PhD research. It's on a chemical injury model. Good morning, everybody. I am Dr. Anam, and I am a postdoctoral student at present in the neurobiology laboratories in Poland. I am going to discuss part of my PhD thesis or PhD research. It's on a chemical injury model. I use cyanic acid sector toxicity injury model to induce the spinal cord injury, and we will use chemical drug to see the assessment or evaluation of that model. If we talk about the introduction of the spinal cord injury, it's a traumatic injury and that lead toward the neurodegeneration, and in last there will be paralysis of a body part. And its pathophysiology is divided into two phases, primary phases and secondary phases. If we talk about secondary phases, glutamate excitotoxicity is an important element in the secondary injury phases of spinal cord injury. So we get an idea, and it was a proposed idea that we can use any glutamate excitotoxin or any agonist that can induce the glutamate excitotoxicity in an animal, and that would lead toward the spinal cord injury. So what we did, we tried to find some drug that would be that is a potent glutamate receptor agonist, and we found that kainic acid is a glutamate receptor agonist, and it's 30 times more potent as compared to the glutamate. So what we did, we planned a study in which we will use kainic acid to induce the spinal cord injury in the steroids. So what we did, after different trials and even pilot study, we found a specific concentration and specific rate of kainic acid, and we induced it into the intraspinal injection. And I have shown into the diagrammatic representation how we induce the injury. And then after inducing the injury and inducing the kainic acid, we observed that over animal with kainic acid induced injured, they lost their like paralysis of their lower limb parts. So they lost the movement of the lower limbs of the like lower limbs. So and then after the injury, we do the difference assessment, like locomotor assessment, to ensure whether our animals have a paralysis and what are the improvement with time. And we observed that our untreated group and injured group show a significant reduction in the locomotor activity, like open field test, running wheel, inverted gait. So we did a lot of tests, sensory function tests, and there was like statistically significant results as compared to the control group. So that indicates that the success of our model that can, so we can induce spinal cord injury by inducing the kainic acid. After 28 days period and of assessment and also treatment, which we use to evaluate whether we can use this model.
मैम हो गया Okay, we will be conducting the poster by the end of session and get it evaluated by the chair and announce the result by the end of the conference. Thank you. Dr. Nasir or Dr. Taqi? Dr. Nasir, Dr. Taqi,
So, of course, moving forward to the second session of the conference, which is dedicated to scientific talks. The scientific talks often provide a platform for researchers, experts, and professionals to share their latest findings, insights, and advancements in their respective fields. It is both an honor and privilege to invite Professor Dr. Sayyid Azhar Inam and Dr. Farhat Abdul on the stage to share the session. Standing on the stage.
हाँ
आपको यहीं बैठना पड़ेगा।
सुनिए डॉक्टर साहब, मैं तो खुश हूँ, तो बैठना ही पड़ेगा।
कोई यहीं बैठ जाता है। पर आपको
All right, without any further delay, Let me introduce the first speaker of this session, Dr. Fazal Manzoor Arani. Dr. Fazal Manzoor Arani, who is an accomplished individual with a strong background in neuroscience, specifically in the area of epilepsy and brain disease. His educational and professional achievements demonstrate his dedication to advancing the field of neurological research. Dr. Fazal Manzoor Arani obtained his MBBS degree from Karachi University, integrating his initial training in the medical field. He holds a notable position as a member of the Executive Committee of the PASBAN Society of Basic and Applied Neuroscience. This demonstrates his leadership and involvement in promoting neuroscience research and collaboration in Pakistan. Today, the topic of this presentation is what makes the human brain. Please welcome Dr. Fazal Arani.
Sir, the pointer is coming. The pointer is coming. The pointer is coming.
Assalamualaikum, everyone. The talk that you just had, and the discussion that we had after that, it has all been very important in order to understand the nervous system that is involved. So in understanding how the whole system is working. And the question always remains, what makes the human brain unique? Why is it? Next please. Yeah. So why are humans the most successful or most powerful species on this planet? If we compare ourselves to all the other species that are present, we are not only the most successful intelligent species, but we have spread all over the planet. And unfortunately, in the process, we have also started to destroy our planet. The species like elephants or whales, they are all, a lot of them are dying. Okay, and if we think about it, we are perhaps the most successful species. Now, a lot of people who used to think about it were thinking that perhaps this is because humans have the largest brain among all the species. Next slide. Next slide. Yes. However, it turned out that as compared to gorilla's brain or dog or any other canine brain, humans definitely had a larger brain. But elephants had 4 times the weight of the brain. And it turns out that whales had almost 9 times the weight of the brain. So how do we say that we are the most smartest or the most cognitively alive species on the world? Because these fellows, they have a larger brain. We do not have the answer to that. However, we look at another And that is the ratio of brain to the rest of the body. If you look at gorillas, it's about 1 to 250. If we look at elephants, it's about 5,000, 25,000 or something. And whales, it is around 1 to 10,000 or even more. Okay. The humans, the ratio is 1 to 50. So if we look at it, our brain is taking up a large portion of our body. Okay, next slide. But brain requires energy. Next slide. Now, if we were to look at how the brain works, it means that every neuron, the finding is so far that 1 billion neurons require 6 kilocalories per day. Now, if we look at species like gorillas, they need 8,000 calories per day, and because they are herbivores, they spend 8 to 12 hours eating vegetables. Elephants, on the other hand, they require 70,000, and that means that they have to spend 16 to 18 hours eating. Okay, and it applies whales. Depending on the age, the size, the sex of the species,
723. 723.
okay, so depending on the age and size and the sex of whales, it can spend the entire day just to get the calories. Okay, so these species are spending such a huge time just to fulfill the requirements, the energy requirements. Okay, and because of that factor, they cannot spend further time doing any other work. Okay, next slide, please. All right, so if you are a herbivore, this means that you are eating vegetables and others. If you are talking about a raw diet, okay, and this means that the energy intake that you have is now divided into 2 parts. One is the energy required by the brain and the energy required by the body. Now, if you want to have a larger body, you cannot afford larger number of neurons. Okay, so next slide, please. Susanna Herculano, Dr. Atharana mentioned her, he did a fabulous study which showed how many neurons we have. And as you can see, that if we talk about this ratio, remember that, as I told you, that 1 billion neurons require about 6 kilocalories per day. Now, if you were to have about 53 billion neurons, in order to have about 6 to 8 hours, okay, you can only allow 25 kilograms. Now, our species that we see around us, they are not 25 kilograms. So what happens is that as the body weight increases, the only way for these species to survive is by decreasing the number of neurons
as they come up. So around 100 kilograms or 75 is where the monkeys and the gorillas, etc., they go on. So their neurons are 12 billion, and that is how it works. Now next slide. Yes, hold on. So if we think about it, humans, as Dr. Athar also mentioned from Dr. Susanna's study, they have 86 billion neurons. And we have a particular size in order to conduct our work. If we were to just eat raw food, we would require a lot of time in order to just fulfill this 86 billion neurons. So how do we do that? The only way that we can do is, next slide please, cooking. What cooking has done is that it pre-digests a lot of food for us. And we do not need to spend 6 to 12 hours just chewing and digesting food. And this allows us to go on and spend a long time for rest of the day. Now, a typical, thank you very much. Okay, a typical human requires just 1 hour for eating, and the rest of the time it is spent on other features that require or help its cognitive abilities. So no other species is doing that. That is why the human species is more effective in this. Now, as I mentioned, that cooking is the key feature of the success of our species. Just take one step back and think about the evolution of human beings. Next slide. Yes. Now, there were other species who also cooked. And we are talking about 1.5 to 2 million years ago, there species like Homo habilis or Homo we, on the other hand, have a smaller brain, larger body. So this brain to body ratio concept does not apply. Why is it that we survived and these fellows did not? Why is it that we are the most successful species at the moment? And nobody knows why it went away, right? Next slide. A very
nice and groundbreaking study actually conducted by Pinson last year, which was published in Science. What they did was they looked at the brain size of Neanderthal and Homo sapiens. Okay, and they said that okay, yes, we agree that Neanderthals also found out that there is a mutation in the gene whole capacity that I've shown, which allowed us to be the most successful species. Okay. Now, if we think about it, this looks very exciting. Please, next slide. Not so fast. It turns out that in a study by Silva et al., they have shown that up to just 3,000 years ago, not too long, just 3,000 years ago, the average weight of the human brain was about 1.5 kilograms. Since then, today, the weight of the human brain is about 1.3 kilograms. The weight of human brain has suddenly decreased. What is the explanation for that? We do not have the answer right now. Next slide. One feature that has shown is that again the size of 3,000-year-old human versus modern human, is that the human brain is shrinking. What is happening over there? So, in order to explain this difference, people have come up with different ideas. Next slide. One of them is self-domestication syndrome. What this means is that we have started to grow our own farms. Okay, we have started to keep like species that we eat, like cows and chicken, etc., so that we don't waste time running into the forest and hunting down a deer.
we just eat that thing that we have kept in our backyard. Now, even worse than that, in today's world, we have divided this into further aspects. Like we don't even go ahead and actually spend time into even doing this growth of crops or other species. Next slide, please. One aspect that can explain this is that there is externalization of knowledge. I think that Dr. also mentioned over here that what we have started to do is that we have started to make these groups and we make group decisions, and that is how quickly we can resolve a problem. We have also started to divide our problems so that there is a speciality for, let's say, we have doctors who don't need to learn anything about engineers, who don't perhaps need to learn about philosophy, but what happens is that for the survival, they all interact, okay, and we get our answer. Is this the fact that we are not using our brain? Next slide, please. The question is, where are we heading to? The thing is that if we look at food, okay, this is the most critical thing that has happened right until the Industrial Revolution. That we spend the most of our time into finding food. But today, we don't need to worry about it. A lot of us simply used to go to a grocery store or buy stuff from there. And even worse now, we order stuff from Food Panda, which comes up to our door. Okay, and we ask somebody else to darwaza kholna aur lekar aana, and you're sitting on your bed and you simply start chewing and trying to digest it. The question is, where are we headed? Is it that we are getting smarter, or are we getting lazier by the externalization of knowledge? A very difficult and complex question, and this is what I'm leaving you with. That how do you explain the reduced size of human brain? And it is a continuous process. Could you go back to a couple of slides? One more. Just one more. That. Now, one thing that I want you to notice that during evolution, it took a long time for us to increase the size of the brain up to 1.5. And then we see this exponential drop, this huge drop within the last 3,000 years of the size of the brain. See how the size of the brain had increased, and now suddenly it has gone down. Where are we headed? Is it that we are going to get dumber and be replaced by artificial intelligence, or are we going to get smarter and control the whole thing? All of these things require answers. So please go further. Thank you. So because I am leaving you to think about your own hypothesis as to where are we headed. Because we took our time to increase the size of the brain, and now we are suddenly dropping it. What does that? Should we be scared of this whole thing. Should we do something about it? Okay. So if there are any questions.
Question answer लेंगे Mike.
Ma'am.
This is that from the Department of Biochemistry. Every grade, make the time allowed to be in the immediate stop paying the tax in the. So same duty from using the other state of the.
It's a very strong sentence that you just said. It can explain that if you are not using, let's suppose that a person had a stroke and after that, that person could not move their arms or muscles. The size of the muscles, they shrink down, they become contractures. All of that can be explained, but the question is that are we not using that brain? Has our brain shrunk down like a muscle that is present in our body? Is it that we just stop, an average person has just stop thinking about all the problems? It's a very difficult question to answer. Just imagine, let's put religion into this. Today, we have these fakirs, right? And they have their followers who just simply follow them without any evidence that their fakir actually knows anything about it. And they don't want to spend time reading Quran or doing research on this, whatever religious issue that they have. So is it that we as an average person are becoming dumber? How is it? Yes. This one thing. After the question,
You actually asked for our own explanation or our own history. So I have an explanation of mine. Can we say that as long as you are discovering new things and you are subscribing on individual basis, as long as you are doing it, it just increase, right? But with the passage of time, I don't think that the consequence of plasticity here and totally says as we move along with time, certain certain connections and kind of reflexive as we do automatically, and now as we are getting lazy and lazy and we are connecting groups and we are not pursuing things individually compared to as we did in the past. So this is what is turning us into like our brain size is getting smaller because some of the things, the patterns are getting automatic and we are not exploring things, new things that could make these connections and increase the brain of science rather getting decreased because we are getting automated. And in connection with this, I have a question, and this question was basically from Dr. But I was not allowed to ask this. Like, I mean, there was a restriction for the time. But my question is that, Dr. You had a great lecture. You were sounding more of a philosopher than a scientist, right? As Dr. Nietzsche would say that there are no truths, but rather interpretations, right? And any interpretation that exists at a point in time is the function of power. So my question from you is, how do you see this influx of technology and the overwhelming of human beings by artificial intelligence. And how do you see the regulations around this? And how do you see the future of humanity in the face of these technological revolutions? Do you think that we need more regulations to lead us into the future, or will we get overwhelmed by the artificial intelligence and technological revolution that we are facing?
We have a mic for Dr. Ather. This is an excellent.
देखिए पहला जैसे मैं जवाब में तो एक डिस्कवर करता हूँ तो जवाब को कुछ पता कॉपी वाला से okay so you know what Professor Ray was saying, understand the difference between the Martian and the Darwinian evolution. So the Martian is not only missionary, the act of the individual doesn't mean an act of the right? So what happens is that there is more ability required to do something with less evidence to automatically disappear from the evolution now. Think about it like that. जो बात है उसकी कि वो कम हो रहा है साइज, don't take it like that because Neanderthals had bigger brain than us, right? And as he mentioned, elephants and dolphins and whales, they have bigger brain. Maybe they are more intelligent than us, but it doesn't look like that. So आज से 3000 साल पहले जो वजन ज्यादा था brain का, it does not mean they were more intelligent. The thing is, it's also possible that we actually have developed over time better way of efficient processing in there. And you know, I mean, the intelligence that I may be, you know, little arrogant over here, but the intelligence that we have here in this room is probably more than it was 3,000 years ago. So if somebody, you know,
Somebody is 3,000 years old, our apologies.
There's much more information that you're processing at this point. Look at this, you know, these lectures and, you know, even हम लोग बुराई करते हैं smartphone. There's so much information that you process in that from there. There's a lot of processing you're doing. So don't take it that the brain is short. It's just that we are becoming maybe smarter and lesser. So उसको लोग करते हैं. जहाँ तक बात आपकी philosophy और interpretation की बात है, वो बहस चलती रहेगी. उसमें मेरा ख्याल ये point है कि you know you cannot जो अपने psychic तस्वीर दिखाएगी that you know God is right. So you cannot just say कि यार ये इसकी वजह से है, we don't experiment that. We want to say what is the physical and biochemical, and we keep on working on that. Instead of putting magic in there and putting the magic carpet, it doesn't help. So interpretation आप करते रहें, new evidence आता रहेगा. Don't stop there. Keep on doing it. I hope that answers your question. Neuroplasticity is shrinking. So we don't know. I mean, we don't have brain to look at the synapses from 3,000 years ago. But neuroplasticity जो है, it actually there is actually a shrinking capability. So as the highest thickest cortex that we have is around the age of 14, 16, in boys and girls, and then it starts to go down. So neuroplasticity just plays an important role in there because you make more synapses and then you start to prune the ones. But does that mean a 30-year-old person is more stupid than a 14-year-old person? No, right? So it's just that it is probably more intelligent. Now it knows if these synapses are useless, let's be more efficient, use these synapses. But then we don't know if this shrinkage in the brain over the last 3,000 years is because of neuroplasticity or not. It may be that we have developed better circuits, and we are working on those. So that's what we do. So don't politicize with intelligence.
Please add to this.
The Sufi philosophy.
The Sufi philosopher, no, sir. Let me clarify. Plasticity, as far as we know, is the ability of the brain to modify its function over time. In most cases, we use that ability to retrain other areas of the brain to learn those things that we have lost. For example, when there is a patient who has lost a part of the brain due to stroke, we rehabilitate them with biofeedback, with exercises, making other parts of the brain take up the function of that area that we've lost. So the brain is plastic in its function, not really in structure. So we're not even sure if the plasticity is because of the reduction in size of the brain or not. Like Dr. Atta said, we don't have the older brains to compare ours with. But plasticity, as we are using the term these days, today, is the ability of the brain to alter function, not the structure. So plasticity of the brain is functional property, not structure. Thank you.
Sorry.
There's one more question here.
There's this phenomena, actually no question.
Here it is.
There's this phenomenon that the general IQ of the overall population are increasing. And that is because of bacteria. So it's very likely that a person who is 3,000 years old is not as smart as a person who is today. That does not correlate to the size of the diet. Right? And with that, the Neanderthals might have a bigger brain, might have been smarter, but it's probably because we killed them or just ended that race. So that's there. My second question was regarding the agricultural revolution. You mentioned the advent of fire and cooking, and then the industrial revolution. But there was another major event in between. That was the agricultural revolution, where humans actually didn't have to hunt and make food. They started agriculture, and they had more time on their hands. So there is this controversy in this, that there's a famous book calling it the biggest fraud in human history, because then you have civilizations, then you have the elites who rule over the leftover food, and then that's it. But on the other hand, what's not commonly discussed is that as humans had more time, they had to calculate the amount of crops they had, and they had to go for economics and then mathematics and then science and everything. That led to a greater advent in their cognition. So this is a controversy. What's your opinion? Was the agricultural revolution a fraud or an important step in cognitive gaining higher cognitive?
It makes a lot of sense that agriculture revolution is making life easier for us and perhaps it is the animal. Only issue is that the effect of the new size of the brain is just 3,000 years ago. So the question then comes in, all of this happened much earlier. Why did the brain start to develop? So the whole reason for my talk today is unfortunately to leave you with more questions than answers. But I want you to think about this whole phenomenon. What is different or special about human brain that is not present in the industry? Thank you.
Thank you very much for an elaborate introduction to that specialist. What I'm going to be talking about today is something of the basis of neuroscience. It's like Dr. Athar said, in an attempt to understand the brain, we were actually going the wrong way. We started studying the minor and the minute parts of the brain in order to make sense of what consciousness and what the brain function overall meant. But the approach that we actually need is the other way around. We need that bird's eye view of what the brain does for us in order to understand the essence of neuroscience, essence of brain function. So what I'm going to talk about today is to enlighten you about how the brain makes us understand the world ये लाइट्स बंद हो सकती है बेटा Okay. Next slide. चलो वो रिमोट पे है चल रहा है that's it. Okay. Say it. So perception of reality, and I'm going to talk about my own perspective of it, not really what everybody else may or may not believe, but it's my perspective on what perception of reality is and my conclusion. I'll take it.
स्लाइड चेंज करने के लिए इनको कहना पड़ेगा
सर 2 मिनट
Okay. It is actually a product. Would it?
ये तो बिल्कुल 60 डिस्टेंस हाँ वैसे डिस्टेंस मेरा पड़ रहा
Oh, yes. You're right. Thank you. Okay. Perception of reality and my own perspective and my conclusion. Can you all hear me well? Thank you. Okay, reality. What do we mean by reality? Reality is the objective truth out there. The objective truth can be in the form of you all sitting there. The objective truth can be in the form of the air that we breathe. The objective truth can be in the form of me talking to you and you understanding whatever sounds are emitted from my vocal cords. So un sounds that you matlab hai, that can also be one form of objective reality. So how do we know that the reality exists out there? उसके लिए अल्लाह मियां ने हमें बहुत सारे tools दिए हैं. There are receptors that we have. There are sensations that they can perceive और उनकी perception के लिए वो receptors मुख्तलिफ तरह के हमारे body में different जगहों पे लगे हुए और उन receptors की वजह से हम लाइट को electromagnetic waves को perceive कर सकते हैं उनकी वजह से perceive we can perceive chemicals in the air in the form of smell. We can perceive chemicals in the material that we put in our mouths in the form of taste. So different sensors हैं और वो in different purposes के लिए structured हैं specifically. Eyes have a specific arrangement of cells that are photosensitive और उनका light इस तरह पड़ती है that they can interpret those rays of light in the form of an image which the brain can understand. अब ये सारी वो चीजें हैं जो हमारी sensations हैं और इन sensations को understand करने के लिए I'll give you an example. We're going out for a walk in the woods and early morning you can imagine the good breeze that you can feel on your face, the warm sunlight that you can feel on your skin, the gravel under your feet, the smell of plants all around you, the green, all shades of green that you can see all around you. अब इन सारी sensations में touch भी है, smell भी है, vision भी है, and all these sensations collectively tell you of the presence of the world around you. And that world, for you, for all practical purposes, is the objective reality. और वो सारी sensations क्योंकि एक दूसरे के साथ in sync है. आपको smell भी plant की आ रही है, अब vision भी आप plant का देख रहे हैं. आपको breeze feel भी हो रही है, but you can also see plants rustling, leaves rustling in the wind. So आपको वो perception visual भी है and tactile भी है of the wind blowing in your face. So all these sensations reality makes an impression of objective reality out there. So क्योंकि ये सारी चीजें synchronized हो रही हैं, you understand that this is what reality is. But हमारे brain में कितने भी ज़्यादा receptors हैं जो objective reality को ना सिर्फ sensory form में perceive करा रहे हैं, जिसमें touch, taste, smell, vision, hearing शामिल हैं, but they can also perceive what you are doing relative to the world around you. So there are sensors that can perceive your position relative to that objective reality. So they also give you a sense of what's going on, what is the real thing around you. They can perceive movement, they can perceive and coordinate the sensory perception जो आपको हो रही है by touch, and there are receptors जो हमें internal perception दे रहे हैं, those of hunger, those of pain, those of cramps, जो पेट में चूहे दौड़ते हैं, उसकी sensation, जब शरीर से नीचे जा रहे होते हैं, तो उसमें वो जो heart sinking की sensation है, जो excitement में या दर्द में result आते हुए, वो जो butterflies in the stomach की feeling है, वो सारी हमारी internal perception है. So there are receptors that can give you a perception of the internal environment as well. All this is very complicated. अब ये integrate भी हो रहा है, perceive भी हो रहा है. इतनी complication के बाद अगर आपको पता चल जाए कि जो कुछ हम perceive कर रहे हैं वो real नहीं है, how do you feel? I mean, it may sound very stupid, but the objective reality that we see, we hear, we perceive is not what's really out there. We are getting an image of what is out there. It's exactly like कि हम जब being doctors, Dr. Atta will bear me out. जब हम CT scan या MRI देखते हैं, तो MRI में हमें brain नजर आ रहा है. We see a tumor. But what we see on an MR or a CT scan is not the tumor. It's an image of the tumor. और वो जो image है, उसको हम in our heads interpret करते हैं as a three-dimensional object somewhere in the skull of that patient, and we try to visualize that reality जिसका वो image है. इसी तरह ये जो सब कुछ हम perceive कर रहे हैं, reality नहीं. Now let me offer you a green and blue pill. What real truth is the blue pill, the red pill. Sorry. Yeah, let me offer you a red and a blue pill. So what is really going to blow you away is the red pill of reality. और वो red pill क्या है? पहली बात तो ये है कि virtual reality. Let's talk about virtual reality. Reality is something which is real, and virtual is something which is not real. So पहली बात ये है कि I don't agree with the term virtual reality. It's a misnomer. It's a paradoxical term, so it should not be there. So I propose another term for this, which is vapor, and which is virtual alternative perception. वो reality नहीं है, it's a virtual perception, and that's an alternative to what the real thing is. So that is what we are to be called, but anyway, I will write about it. क्योंकि और किसी ने नाम कर रख दिया तो कम से कम मैं claim तो कर सकूं कि ये मेरा suggested नाम है. We are a predominantly visual object. हमारी जो impression of reality है वो mainly vision based है. So I'll be a little quick because there are so many things I have to tell you about this, and I have a tendency of getting carried away in my own flow of thought. So I'll try to restrict myself. Vision, हमारा primary modality है of experiencing the world around us, and brain जो हमारा जो perceive कर रहा है वो सिर्फ वो light senses जो हमारे ऊपर light rays आ रही हैं जो retina की different layers पे आ रही हैं वो सिर्फ वो नहीं perceive करता, brain उनको interpret भी करता है and gives it meaning. So brain is not just a light receiving and perceiving organ. It understands what it's perceiving and it recognizes the pattern. मुझे एक red एक curve shape में अगर नजर आ रहा है तो वो curve shape में मुझे यहाँ पे पता नहीं लगेगा, मुझे लगेगा कि किसी के सर पे red पड़ता है. So I understand the pattern in reference to the context around me. Therefore, brain recognizes the patterns. What is a sensation? Sensation is just receiving a stimulus and perceiving it. So sensation का मतलब है कि हमें light भी महसूस हो रही है, हमें sound भी महसूस हो रही है, हमें touch भी महसूस हो रहा है. But it's a passive phenomena. Light होगी तो perceive होगी, and it is limited. Limited इस तरह कि हम लोग सिर्फ उसी चीज को perceive करेंगे जिसका हमारे पास receptor है. मेरे बॉडी में वाईफाई का रिसेप्टर नहीं, जितना मर्जी आप मेरे साथ कनेक्ट करने की कोशिश करें, I do not. Similarly, I do not respond to infrared. You may have remote control और आप मुझे control करने की कोशिश करें, I probably will not respond to it. क्योंकि मेरी बॉडी में infrared का कोई receptor नहीं है. इसी तरह there are so many other things we do not have receptors for. Birds have a receptor for magnetic field. Imagine those birds that navigate their way around the globe when they're migrating. They use magnetic field around them, Earth's magnetic field. और वो उस magnetic field को perceive करते हुए वो एक continent से दूसरे continent तक migrate करते हैं, thousands of miles across the sea. उनके पास अल्लाह मियां ने एक sensation दी है, which we do not have. So sensation is a passive phenomena and it's limited only to receptors that we have. दूसरी बात इसमें ये भी है कि वो आगे जाके बात करेंगे कि वो सिर्फ limited to receptor नहीं है, वो जो receptor भी है वो पूरे range को respond नहीं कर रहा, वो उसकी भी एक sliver of fragment को respond कर रहा है. Anyway, दूसरी बात है perception, उसका interpret करना, उसको meaning देना. That's an active phenomenon. So brain doesn't only receive a sensation, it perceives it, it gives it meaning. वो light को vision के साथ सिर्फ एक as a sensation perceive नहीं कर रहा, it gives it a meaning. And since it gives it a very first degree of meaning. We call it a level 1 meaning, and still that makes it an active phenomenon. It's made to perceive something, you have to have a brain. Photoreceptor can respond to light, or आप उसको अगर connect करें to a galvanometer, so you can detect the response of the cell. But उसको perceive करना as light, you need to have a brain. तो वो खाली sensation को perceive नहीं कर रहे, उसको interpret भी कर रहे हैं. और चूंकि interpretation में brain involved है, brain की अपनी बहुत सारी input उसको alter करती है perception को. It's not a limited phenomenon. It's not limited to what is coming in. वो जो perception है, वो meaning है that can alter based on other inputs जो brain में हैं, उसकी अपनी memory, उसके बाद experience, उसकी modification, severity की, intensity की changes. तीसरा integration. Integration का मतलब है कि उस sense को दूसरी senses के साथ integrate करके एक meaning से है. अगर आपको मेरे lips हिलते हुए लग रहे हैं और साथ in sync with that, you can also hear me speak, so that the brain will interpret that thing as me talking to you, and it will make it easier for you to understand what I'm saying. बहुत सारी दफा वो लोग who are hard of hearing, when they can't make sense of what is being said, they learn over a period of time, they learn to lip read. वो उनके बोलने वाले के लिप्स की मूवमेंट से प्लस वो जो थोड़ी बहुत साउंड आ रही है उससे वो अपना मतलब समझना शुरू हो जाता है. So integration of senses again is an active phenomenon. It's a brain function. Conjugation जिसके अंदर आप सारी sensations को मिला के एक मतलब देते हो, उसको हम conjugation of senses कहते हैं. Since humans are primarily a visual organism, हमारे अंदर most of the cortex, जो sensory cortex है, वो visual interpretation के लिए यूज होता है. Actually, cortex के बहुत सारे जो सर बार बात कर रहे थे आप लोगों के साथ कि association areas are what make us superior. Association areas are interpretative areas. और वो जो association areas हैं, sensory association areas, वो सिर्फ एक sensation को process नहीं कर रहे. The same area is being used to interpret a lot of things. तो हमारे जो vision की interpretation है, that uses up almost half of the total sensory areas, including the primary, including the secondary, including the association area. और उस processing को other animals different तरह से करते हैं. Dogs are basically olfactory animals. उनका visual process इतना ज़्यादा strong नहीं है. Bats are mainly auditory animals. उनकी जो image of the 3D world around them है, वो बनता ही वो जो bats की echolocation की ability है उससे बनता है. तो जो मुझे कमरे में आप लोग बैठे हुए नजर आ रहे हैं और एक sloping सा ये मुझे field सामने नजर आ रहे हैं, bats को भी इसी तरह हो रहा होगा, लेकिन वो नजर नहीं आ रहा होगा, वो सुनाई दे रहा होगा. And try to imagine कि वो कैसे perceive करेंगे आप. अगर यहाँ पे if there's a bat sitting here and trying to echolocate the surroundings around it, it's throwing off clicks and it's receiving reflection of those clicks. और वो sound से उसका एक 3-dimensional image बन रहा है of the space around. That is going to be totally different from the image that we get using our visual senses. Cats, there are cats. आपने नोट किया है because of the lack of pigment in their retina, cats की light रात को आंखें shine करती हैं red because they do not have the pigment that absorbs light in their eyes. इसी तरह cats के जो photoreceptors हैं, they respond to infrared light as well. That's why cats can see and navigate very well at night in the light that we cannot perceive. So आप cats को imagine करें जैसे आप infrared goggles use करते हैं या night vision goggles का जो एक image आता है कि वो shadow सा बंदे का move कर रहा है. Probably that's how cats see us. Try to imagine living in a world जिसमें सिर्फ वही नजर आ. So their world is very different from our world. Their perceptome, जो पूरा perception का एक collective image है, वो बहुत different है from the image that we get. I'm sorry, I'm taking long. Dog whistle एक बहुत अच्छी example है. There is a whistle available जो dog trainers use करते हैं. whistle blow करते हैं तो दूर से भागा हुआ dog वापस आया, and you do not hear anything because it's supersonic. It's in a frequency range which is beyond our hearing, but the dogs can respond to it. इसी तरह bats का भी जो sonic vision है, मैंने उसकी picture बड़ी ढूंढने की कोशिश की, मुझे negative मिली नहीं, otherwise I would have shown you what the world looks like to a bat. Anyway, मैं ये बताना चाह रहा हूँ कि हमारी sensation की limit होना सिर्फ sensory receptors की वजह से limited नहीं है, वो इसलिए भी limited है कि जिस sensation का हमारे पास receptor है भी, वो बताते खुद बहुत छोटी सी fragment of that sensation को respond करता है, not the whole of the spectrum. Electromagnetic spectrum बहुत बड़ा spectrum है. It has ultraviolet, it has infrared, जो microwave और background radiation में चली जाती हैं. Images आपने देखे होंगे जो अभी जेम्स वेब टेलीस्कोप से बहुत सारे सोशल मीडिया पे आ रहे हैं. They are extremely good resolution images. That's because James Webb is way out in space and is having much bigger mirror. But also, एक galaxy के अंदर उसके spokes दिखाए हैं जो कि पहले जो हमारा Hubble Space Telescope है उसने भी नहीं दिखाया. Because the Hubble was not sensitive to infrared light. Hubble is a visual spectrum telescope. James Webb is an infrared telescope. So James Webb receives the infrared light. James Webb can see things Hubble could not. तो इसलिए जो हमारे receptors हैं, ना सिर्फ हम सिर्फ वो चीजें कर रहे हैं क्योंकि receptors हैं, हम उनका भी बहुत थोड़ा हिस्सा perceive कर रहे हैं. सर ने आपको एक बड़ी अच्छी डायग्राम दिखाई थी साउंड की, जिसमें वेव का साउंड परसेप्शन का स्पेक्ट्रम अलग है, माउस का अलग है, ह्यूमन का अलग है. मैं उसी तरह की आपको एक विजन की थोड़ी सी ज्यादा स्टार्ट एग्जांपल दूंगा. हमारा विजुअल रिस्पांस जिस स्पेक्ट्रम में है वो बहुत डिफरेंट है. ये वाला है. और जो बर्ड्स का विजुअल स्पेक्ट्रम है, they have 4 kinds of colors. So उनकी जो color vision है वो बहुत different है compared to us. और ये कई दफा होता है कि when we have pet birds, हम सोचते रहते हैं कि यार इसमें से तोता कौन सा है और तोती कौन सी है, because they both look similar to us. ठीक है, कुछ तोतों में deep green होती है या blue होती है या कुछ red होती है, but there are species जिनके कब्बे का नहीं पता चलता कि कब्बा कौन सा कब्बी कौन सा. तो नहीं कभी लफ्ज है भी के लिए, but anyway कब्बा जरा कहते हैं दूसरा लगता है. तो कब्बे का मेल कौन से और फीमेल कौन से है, we don't know, right? But there is a bird. Birds have no difficulty deciding to which bird they need to dance to and to which bird they don't need to dance to, right? वो इसीलिए है because they just by visually looking at another bird can tell which is the male and which is mother. इसी तरह birds में जो हमारे vision में हमें black भी लग रहा है, उसके अंदर कुछ ऐसे infrared जो ultraviolet colors हैं जिनको हम respond नहीं कर रहे, but the bird can very easily see those colors. तो colors होने के बावजूद हमारे पास बहुत limit है हमारे vision frogs. Just because their eyes are projecting above their skull, so उनका जो exposed cornea है much bigger than ours, और उसकी वजह से उनका field of vision, ये जो range है पूरा जिसको वो respond कर सकते हैं वो बहुत बड़ा है. Anyway, बताना यही चाह रहा था. हाँ, हॉकी सर ने example दी, luckily मेरे पास हॉकी was तस्वीर है सर उसकी retina, and interestingly a hawk's retina has 2 foci. उसका एक फोबिया नहीं है. वो जो sharp focal point है वो 2 है. One the hawk uses to spot things at the distance, and the other one is what it uses to focus on things on either side. So hawk के retina में 2 focal points हैं जो sharp focus देते हैं, और वो side से prey भी देख सकता है और नीचे से उसका victim क्या है उसको भी देख सकता है simultaneously. तो विजन का हमारा कोई सुपीरियरिटी नहीं है ओवर अदर, फिर भी हम विजन को बाकी एनिमल से बहुत ज्यादा इस तरह समझ ले just because हमारा जो प्रोसेसर है vision का वो बहुत strong है। How many of you have Android phones? Show of hands. And how many of you know what megapixel camera your phone has? Okay, I see quite a few hands. How many of you have iPhone? And how many of you iPhone users know what camera it has? None. Oh, you do, man. You. So the point I'm trying to make is, yeah, Android में 40 megapixel cameras आ रही हैं, उनकी picture capture करने की quality is way superior than an iPhone. iPhone कभी भी अपने पास ये नहीं declare करता कि iPhone 10 में कौन सा कैमरा है, because the camera per se is not superior to an Android phone. उसके काफी inferior resolution के कैमरा, but picture quality में it almost always surpasses an Android. Why does it do that? How can it do that? Because the processing of an iPhone image is way superior than what an Android. The iPhone uses the same thing that our brain uses to use an inferior receptors, but to make an interpretation which is way superior than any animal can. So हमारे vision की processing है वो बहुत फर्क है. And if you look at it, इसके अंदर almost सारा brain use हुआ है. हमारा visual cortex तो पीछे है. हमारा visual cortex is basically the occipital part. लेकिन उसके कहीं पे वो vision की movement को perceive करने की interpretation कर रहा है, कहीं पे उसकी color vision की shape को interpret कर रहा है, कहीं पे वो recognize कर रहा है, कहीं पे वो cerebellar influences ले रहा है, कहीं पे वो अपनी temporal lobe से memory ले रहा है, objective identity so on and so on. बहुत सारी processing is what makes our really superior. अब ये सारी बातें तो होती हैं, इतना कुछ superior तो हो गया है, but ये मैं बात करूँगा, but इसका मतलब ये होना चाहिए कि हमारा जो vision है वो थोड़ा तो है, but it's fair से. इसका मतलब है कि जो हम देख रहे हैं वो exactly वही है जो actually out there. No, it's not. What do you see here? Yes. कोई गुलदान पड़े हुए हैं, वैली हैं, और apparently उनके कलर से लग रहा है कि लकड़ी के हैं. ये तस्वीर आप लोगों ने बहुत दफा देखी होगी, ये बहुत commonly नेट पे अवेलेबल है. It's a base, नीचे उसका base है, ऊपर फूल रखने की जगह है. What do you see here? Two faces. अब आपको क्या नजर आ रहा है? अब वो faces आपको इसमें भी नजर आ रहे हैं. The four faces which you fail to see in the first floor. The brain ने उस सारी processing के बावजूद faces recognize नहीं किए क्योंकि उसके processor ने आपका ध्यान इन shadows की तरफ डाल दिया है. You were concentrating on what was in between the faces. अब दोबारा देख के इन faces के दरमियान में जो space है, can you make out figures in that space?
Yes.
Yes. There are people standing and talking to each other with faces down, right? ये वो चीजें हैं जब हमारा vision पहले क्यों हमें नहीं दिखाता, क्योंकि vision खुद इंटरप्रेट करने की कोशिश करता है उस इमेज को जो हमें नजर आ रहा है. और ये ability हम यूज करते हैं to distinguish between a computer and a human being. जो आप कई वेबसाइट्स पे जाते हैं तो अब वैसे क्या irony of nature है, हम ये डरते हैं कि कहीं कंप्यूटर हमारे से superior ना हो जाए. कंप्यूटर हमारे से पूछ रहा है कि प्रूव करो कि तुम इंसान हो. How ironic, right? This is a CAPTCHA. CAPTCHA means completely automated public Turing test to tell computers and people apart. CAPTCHA क्या होता है? आपको कंप्यूटर अक्सर कहता है कि आइडेंटिफाई के ट्रैफिक लाइट्स के सिग्नल्स दिए हुए हैं, या आइडेंटिफाई करें कि मोटरसाइकिल कहाँ पे है, या ये लेटर्स क्या नजर आ रहे हैं, ये करें. वो इसलिए कहता है कि जो ये कर सके वो क्यों. The computer cannot tell you what letters are written if they are not in the exact shape of letter. The computer की सिर्फ लॉजिकल सेंस है, उसके अंदर ये इस तरह की क्रिएटिव सेंसेशन नहीं है, क्रिएटिव परसेप्शन नहीं है कि वो टेढ़ा मेढ़ा होने के बावजूद परसीव कर ले कि ये एस एम डब्ल्यू एम का, ये सिर्फ ह्यूमंस में है। What do you see here? दो खवातीन साथ साथ खड़ी हैं और दूसरी छोटी है। This is called an Emmy's room experiment. Emmy's room एक वो कमरा है जिसकी एक वॉल के साथ आप खड़े होगे तो आपका साइज बहुत छोटा हो जाएगा और दूसरी वॉल के साथ खड़े होगे तो ये एक ही खातून है, उसकी तस्वीर है when she is standing on the right and when she is standing on the left. How can she grow so tall? It's not because she is growing tall or there is anything happening to her. It's because the room is huge. एक दीवार बहुत दूर है, एक दीवार बहुत करीब है। But why can't you perceive the walls like they are? वो इसलिए कि जो उसके फ्लोर पे पैटर्न है, वो फ्लोर के पैटर्न को उन्होंने इस तरह बनाया हुआ है कि वो आपको लग रहा है कि ये फ्लैट है, आपको लग रहा है कि वो दीवार बिल्कुल फ्लैट सामने है and you're looking at it at right angles. ये प्रोसेसिंग ब्रेन के अंदर हो रही है और उस प्रोसेसिंग को आप उतनी ही आसानी से once you understand what it is कंफ्यूज कर सकते हैं, क्योंकि एक बहुत कॉमन एग्जांपल ये है, आपने गोल्डफ्लो केएफसी और किंगडम वैली का पेंट लिखा हुआ देखा है, ये क्रिकेट मैच इंडिया पाकिस्तान और न्यूजीलैंड के दरमियान था, दिस वाज लाइक 2 months ago और मैंने टीवी पे आ रहा था तो मैंने एकदम से सीख नहीं जस्ट बिकॉज़ आई वांटेड टू टेल यू कि ये किस तरह बन रहा है। आप नोट करो तो गोल्डफ्लो का बोर्ड खड़ा हुआ नजर आ रहा है, राइट, ये वाला। इसी तरह किंगडम वैली का भी खड़ा हुआ है, पीछे बकायदा शैडो भी नजर आ रहा है। बट यू नो व्हाट दीस थिंग्स आर, वो पीछे भी आपको वो खड़े हुए नजर आ रहा है और ये वाला, राइट। और you know what these things are? These are what is painted on the ground in a way कि आप इस एंगल से देखो तो आपको वो लगे कि वो खड़ा है। How can that be? ये वो नजर आ रहा है, वो देख, वो इतना फ्लैट करके उन्होंने बनाया हुआ है कि while looking at it वो आपको right angles का impression देगा। It's not the right angles that have been drawn. They've drawn it in the form जो अगर right angles पे होता तो इस तरह, you get it? So हमारी visual sensations बड़ी easily deep हो सकती हैं। How can these two be so different inside? They're not. That lady is actually sitting way away compared to the guy standing closer. वो सिर्फ ये है और आप दोबारा भी अगर देखो तो आपको फिर भी ये नहीं लगेगा कि वो खातून को बैठी है, क्योंकि हमारा ब्रेन में इंटरप्रेट ही ऐसे कर रहा है, क्योंकि 4 टांगे नजर आ रही हैं तो वो आपको लगेगा कि कुछ ही है, कि आप कभी परसीव नहीं कर सकते जो कुछ है बहुत। I don't know ये इस तरह स्क्रीन में पता चल रहा है कि नहीं, but when you look at it up close you see a certain movement in it, ये चीज घूमती ही नजर आ रही है। That is only because ये जो ओवॉइड बनाए हुए हैं उनकी एक तरफ ब्लैक है एक तरफ व्हाइट है और वो हमारा ब्रेन उस ब्लैक व्हाइट को परसीव करता है एज मीट। इसके अंदर ये आपको स्क्रीन करते हुए लग रहे हैं, अगेन यूजिंग द ब्लैक एंड व्हाइट थिंग्स टू रिसीव योर विजुअल सेंसेशन फॉर मूवमेंट। सेम कैन बी डन विद योर हियरिंग सेंसेशन। हमें आंखें बंद करके एक तरफ से आवाज आती भी पता चल जाती है, किस तरह पता चलती है? One of our ears receives that sound earlier than the other ear, और वो पहले आती है जिसके अंदर सा आवाज, उससे हमें आइडिया हो जाता है कि वो डायरेक्शन किस तरफ आ रही है, राइट। अगर आप इसी को हेडफोन्स के अंदर अलग-अलग साउंड फील करें each of your ears, आप आंखें बंद करके जब इमेजिन करें आपको थोड़ा दौड़ता हुआ पता चलता है कि आपकी राइट साइड से गुजर गया है कि लेफ्ट साइड। आपको ये पता चल जाता है मोटर बाइक पीछे से आ रही थी, अभी वो मेरे राइट से गुजर भी गई है कि लेफ्ट से गुजर, क्यों? क्योंकि राइट साइड वाला ईयर साउंड ज्यादा परसीव कर रहा है कंपेयर टू द लेफ्ट। दिस इज कॉल्ड स्टीरियो साउंड। तो वो स्टीरियो साउंड भी आपको उसी तरह परसीव कर देते हैं, रिसीव कर देते हैं। एंड व्हाट इफ यू कंबाइन दीस perceptions into an integrated whole? That is what we are at. We are creating reality around you, deceiving your senses into believing that this is real. वो visual perception को भी कर रहे हैं, वो hearing को भी कर रहे हैं, और अब कुछ चीजें इतनी ज्यादा डेवलप हो गई हैं कि वो आपको इसमें तो कुछ नहीं निकल रही है, तो सॉरी, जिसमें वो 3D जो बोलते हैं सिनेमाज हैं, 3D सिनेमाज की चेयर वाइब्रेशन, 3D cinemas में आपको palm of their left side से लगता है तो आपको एकदम यूजली टाइप, so they can really confuse you in this orientation, even knowing कि ये गलत है, उसके बावजूद your body starts to react according to what it's perceiving. और there is this very famous virtual reality game, it's called the Plank. और प्लांट में सिर्फ ये नजर आ रहा है कि यू आर एट द टॉप ऑफ लाइक skyscraper 100-story बिल्डिंग और कोई कंस्ट्रक्शन के फटे नहीं होते, वो एक प्लांट है जो थोड़ा सा आगे गया हुआ है एंड यू आर ओनली आस्क्ड टू वॉक टुवर्ड्स द एंड ऑफ द प्लांट. आप पता है कि आप पीआर के अंदर हो, आपको पता है कि आपने गॉगल्स पहने हैं, आपको पता है कि मैं स्टेज पे खड़ा हूं और मेरे इर्द सॉलिड ग्राउंड है, you cannot walk that path. It is so real. और ये उन्होंने एक्सपेरिमेंट्स हुए थे इन हार्वर्ड, MIT वालों ने किए थे यही सेंसेशन को रिसीव करने के लिए, यूजिंग वॉलीबॉल प्लेयर्स, यूजिंग फुटबॉल प्लेयर्स, यूजिंग वो जो कंट्री बाइसिकल रेस करते हैं उन, मतलब वो लोग जिनकी बैलेंस सेंसेशन बहुत स्ट्रांगली डेवलप, none of them could actually complete the walk. 4 or 5 steps walk at the end of the class. वो हो ही नहीं सकता क्योंकि आपका ब्रेन जो परसीव कर रहे हैं उसको रियल जाए. तो मैं बताने के चाह रहा हूँ कि हमारी परसेप्शन is not really the reality out there. Our perception is an image of the reality that our brain produces. The reality, for all that we know, may actually have changed, and our brain will continue to repeat what we think. And same is, this is a very famous paradoxical problem they give you when they're teaching you about philosophy and about especially about Zen Buddhism. Monks को ये practice mind में practice करने के लिए दबा देते हैं. ये सारी चीजें तो हो गई. Sound is actually a sensation that the brain perceives when certain air waves hit the diaphragm, hit the eardrum. और वो air waves जब hit करेगी तो sound आपको perceive होगी in the brain. खाली air waves hit करते हैं और वो nerve ना हो तो आपको sound नहीं आएगी, right? So what is sound? Is that sound just the waves जो हवा में आ रही हैं, या वो brain का जो perception है वो sound? तो हम सब हैं साइंटिस्ट, हम सब यही कहेंगे कि वो जो ब्रेन की परसेप्शन है साउंड तो वो है, वेव्स आर जस्ट एयर वेव्स. साउंड तब बनेगी जब वो ब्रेन उसको इंटरप्रेट. नाउ इफ अ ट्री फॉल्स इन अ फॉरेस्ट and there's nobody there to hear it fall, has the tree made a sound? How many of you say yes? And how many of you say no? And how many of you are confused like me? You're all. I don't know, but sound तो वो है जब आप perceive करते हो. और अगर आप हो ही नहीं, there is nobody there to perceive it, वो sound waves जो हवा में जाती हैं वो तो बनाएगा. लेकिन sound as such होगी कि नहीं होगी? I don't think होगी. I'm very happy about that anyway. So, in all probability, no. The sound is the answer to the question is a no. इसी तरह बहुत सारी चीजों के बारे में हम बात कर सकते हैं. Time is an illusion. Time के बारे में तो हम इतने specific हैं कि जो मर्जी हो जाए, time तो चल रहा है. हम सारी दुनिया को still भी कर दे, तो टाइम तो गुजर रहा है, राइट? सो टाइम के बारे में हमारा एक इतना ज्यादा subjective experience है कि time reverse नहीं हो सकता, we can't go back in time, we can't go ahead in time, time is passing, there is a fixed speed जिसके साथ चल रहा है, वो कभी-कभी relative हो जाती है depending on कि आप किसी गूगल से गाड़ी वाले के लेक्चर सुन रहे हो या किसी मूवी में बैठे हुए हो, so relative तेज और slow तो हो जाता है, but it continues to pass, right? That's what we all believe, but mathematically बहुत सारे scientists, even physicists now agree that time is unreal. Time is just what we perceive. Interstellar decision. Interstellar, when he enters the cataract at the end, and he sees time, तो time देख रहा है. All the future and all the past exist simultaneously. So time, that's weird, right? I know it's weird. लेकिन that's actually what physics say. So time के बारे में एक और simple सी मैं आपको मिसाल दे देता हूँ, यही मैं बता रहा था, even if the आता है. There was another study done at UCLA in which they timed the trained runners, वो जो 100-meter sprint लगाते हैं, उनको जो trained athletes हैं, उनको उन्होंने time किया कि जिस वक्त वो गन शूट करते हैं, that's when the runner starts running, and they timed the interval between the actual firing of the gun and the actual start of movement in the runner's muscles, and they found out the runner starts responding almost always way before he's aware of the sound of the gun. अब ये इतनी weird बात है कि उसके ब्रेन ने भी साउंड परसीव नहीं, but the runner starts running. उसकी बॉडी इतनी ट्रेन हो गई है कि उधर से साउंड आती है, पर वो परसीव करेगा तो भागेगा ना, उसकी बॉडी में परसेप्शन ही नहीं होगी तो भागेगा कैसे? But yes, they start running. उसका मतलब ये है, उसकी एक सिंपल लाइफ मिसाल भी है. वॉकिंग बेयरफुट कोई वाली वो खास की खूबसूरत सी पार्क में वॉक किया, आपको मिसाल दोबारा ले लो, आप पैदल नंगे पांव घास पे चल रहे हो, एंड समवेयर इन द मिडल यू स्टब योर टो अगेंस्ट अ पत्थर और अगेंस्ट यू हिट अ थॉर्न, और वो कांटा चुभ जाता है पांव, क्या होता है? आप एकदम आउच करके टांग खींचते हैं, राइट? The time it takes for you to respond to that stimulus is way less than the time it takes for you to be aware of the pain. We confirm that. That's how reflexes work. उधर से painful sensation गई, साथ ही muscle twitch हो गया, और वो stimulus बहुत बाद में brain तक पहुंचा, and you felt के pain. But कितनी दफा आप लोगों से पूछें जब पेन हुई थी तो आप सबको यही लगेगा कि मुझे पहले पेन हुई है तो मैंने कहा. So they went back to the runners, they asked them कि आपने क्यों भागना शुरू कर दिया? उसने कहा कि मुझे फायर की आवाज आई थी तो. So वो नर्व्स की कंडक्शन, उसका टाइम, आवाज के पहुंचने का टाइम, सारा कैलकुलेट करें तो वो टाइम बहुत ज्यादा था और वो भागना पहले से. तो ये सारी तमहीद बांधने का मेरा ये है कि there is nothing as an absolute time.
इनको बताना
Thank you. There is nothing like absolute time. There is an organ, a structure in the brain that perceives time, and it's called a time correcting area of the brain. Entorhinal cortex है, which makes you believe. Sorry, I'm done. मैं इतनी बंद कर देता हूँ. बहुत सारी लंबी बातें हैं, but this is not. The only point I'm trying to make is ये हिस्ट्री को स्किप कर जाते हैं. I just go to the concluding slide. Galileo, जो डॉक्टर अथर ने डिकार्टे की बात की थी, it's not just डिकार्टे, गैलीलियो ने भी यही बात की थी कि दो प्रॉपर्टीज हैं रियलिटी की, the external property और the internal property. Anyway, consciousness, reality, and C. Escher. I would encourage you all एक दफा घर जाके look him up, MC Escher, and look up his drawings. He just used to use pencil to draw, or he would always draw three-dimensional space, and he would always draw paradoxical space. Just to give you the idea that reality is something that you can model. Anyway, we're losing slide, sorry. Okay, this is particularly slide. Even पुराने पाठ में कहा हुआ है. अब ये देखो, all this looks very real, right? आपको एक पोस्ट नजर आ रही है, तो दूर पहाड़ है, where you can imagine standing there, you can hear the sounds of the ocean, you can see everything there. What would you say if I told you it's just an illusion? And the life of the world is over, is to Imran की आयत number 40. और उसमें बड़ा clearly वाज़ेह तौर पर लिखा हुआ है कि ये सिर्फ illusion है. Illusion क्या होती है? Anil Seth is a scientist in California. उसकी एक book आई है, Being You. The book is about our perception of reality, and he says what we perceive is a hallucination. I disagree with him. It's not a hallucination. He calls it a structured hallucination. Hallucination होती है you have a perception without a stimulus. हमें stimulus नहीं मिल रही है. This is not a hallucination. I call it an illusion. Illusion का मतलब है कि वो जो चीज आप perceive कर रहे हो वो ऐसे actually नहीं. So I will end my talk here. The point I was trying to make is that the reality may be very different from what we perceive, and the reality that I perceive will be very different from the reality anybody else perceives. Thank you very much. Really sorry for taking so long. I told you I get carried away. I know there are a lot of questions we need to ask. I will display my email and my WhatsApp number. So you're all always welcome to send me message, ask questions, and जब तक my conference चल रही है तब तक I'm available. Just before I go, I'll tell you next हमारी जो annual national conference है, it's being hosted in Lahore. But ये हमने flex यहाँ पे display किया, मैंने वो slide display करनी थी. फिलहाल, just to give you a brief idea of where and when it's going to be, you're all welcome to Lahore next year, inshallah. Thank you very much.
Thank you so much, Dr. Nasir, what an amazing talk. It really got us all thinking around us. So without delay,
Thank you very much. Thank you.
Dr. Rocky and her impressive credentials showcase his significant contributions to the field of pharmacology and neuroscience. As a professor in the Department of Healthcare, Biotechnology, and he holds a prominent position in the academic. With over 13 years of as the extensive expertise in research and academic leadership. He is also a visiting professor of neuroscience at Johns Hopkins University. Today, the topic of his presentation is matters neurotoxicity, cellular molecular network and cellular effects. Please welcome Dr. Tawfi Ahmad on the stage.
Thank you. Thank you.
Wonderful day so far, full of learning. Thank you so much, organizers. for inviting me and giving me time to talk about my research. I'm thankful to Professor Dr. PASBAN, Dr. and the whole organization team, faculty members, students, all those who are sitting here. Thank you so much. So let's start. अभी तक हमने I think ये बात बता रखी थी कि brain सबसे important होता है. So that's clear. तो इसकी जो अहम चीज है या जो इम्पोर्टेंट चीज है फिर उसको प्रोटेक्ट करना भी उतना ही इम्पोर्टेंट हो जाता है ताकि वो काम करती रहे सही से. So when I came back to Pakistan, I started working in the field of neuroscience, and especially I switched my field to the metals neurotoxicity because that is the problem in the developing countries. We are having contaminated water and contaminated, like many things are contaminated, environmental pollution. And my field is especially on the metals neurotoxicity. And today's title is like cellular, molecular, network, and behavioral effects. But we can imagine that in less than 20 minutes, I will try to be within 20 minutes. Within 20 minutes, you cannot talk each and every day. So I will briefly talk about some of the research that we have done in the last 8 to 10 years, and so that we get an idea that what we're like, how metal neurotoxicity is affecting our brain, and how that affects behavior. That will be the major focus of my talk. So this is location where I'm currently serving. I'm serving at the NUST, Autonomous School of Applied Life Sciences, and you can see. So you can see this is the building where I am, and across the road is the animal house where we do a lot of behavior. I'm interested in behavior neuroscience a lot because that is one of the areas that I was like specialized. Next time, please. Okay, so now coming back to the same topic, the Marco कैसे protect करके रखना है. So we are exposed to the variety of metals, environmental pollutants. Especially here we stand, and there are many things basically which are actually contaminating the environment. There are sources of heavy metal from the industrialization because of the packaging of the food, use of chemicals in the industry, plasticizers, paints, and everything. And from these actually environmental chemicals, exposure, the metals basically go to the agriculture products, and then we are exposed and they cause like a lot of different types of pathologies, carcinogenicity, mutagenicity, but they also cause neurotoxicity, which is like actually dealing with our like high cognitive function. Next slide, please. So I thought like it's very important to share like what is the fact about how much contaminated our water and soil is. That basically is shown a couple of reviews, excellent reviews by these groups. So there are like you can like go into the detail and see those reviews, but you can see that the arsenic, lead, and aluminum, they are way more than the required limit that is basically, and these are the dots basically the studies done in different parts of the Pakistan where we are reporting that the metals concentration or neurotoxic or heavy metals, we are like well above the level that is recommended. It means all of us, not only me, all of us, our children, grandparents, everyone is exposed to those metals. Next slide, please. And I also like shown a couple of like these on the couple of slides, but you can like search and you can find that here is a lot of like literature about the heavy metals in the water, blood samples, brain samples, and the hair samples. And only the problem in the developing country. The problem is also of the developed countries because of the industrialization. And in the US, if you go, your kids go to the school, they ask you to have the lead levels before school, the kids come into the school. Because before 80s, the buildings or the paints, they were having high amount of lead. So that is basically now contaminating the environment. So this is amount of the mercury that was actually believed by the different states, you can see that the problem is all over across the US, where you can see the South Coast, I think, kind of like Florida, other states, and also like spread all across the US. So like I will talk about three questions that we have like tried to answer, but partially like we are trying to understand the mechanism based on three questions. So the first question is is like how the metals exposure, or especially in our case, aluminum exposure, is causing behavioral impairments. So we expose animals next slide and next slide. So when we like the environmental condition, when we were exposed the mice to the aluminum exposure, and then we tried to measure the aluminum concentration in the brain, and we found out that compared to the control, aluminum treated animals, the concentration per gram of the tissue is much higher.
moving on to the next session, session 3 of the conference, which is oral remedy session. And I would like to invite Professor Dr. Tommy and us to chair the session and Dr. Shaista Imar to co-chair the session. Sir, Dr. Tommy and please come on the stage. Yeah. And Dr. Shaista Imar. There is an announcement. It was something
Why are we saying so? We have
like without any further delay, let's move on to our first part of the session by Ravi. Ravi says, please come on the stage. Please welcome her on this stage. Assalamualaikum. This is Rabi from Department of Biochemistry, University of Karachi. And today in the
open and we'll
For this session, required to our chair and co-chair, respected chair and co-chair, Professor Dr. Nasser, Rosa Awad, and Professor Dr. Karachi. I would like to invite and speaker is Dr. Burhan Iqbal, Associate Professor of Robotics Department in the Harvard with Earlier University. His background is incredible. It's a PhD in neuroscience from Medical University of Vienna, Austria. Postdoc in molecular
वीडियोस हैं जो चलेंगी मैं आपको बताऊंगा आप इसके ऊपर क्लिक कीजिएगा तो वो खुद बहुत चल पड़ेंगे पूरा फोल्डर आपने कॉपी कर लिया था ये पॉइंटर को
First of all, thank you very much, organizer, for inviting me and present some of our results to this audience and upcoming neuroscientists of Pakistan. I'm continuing where Dr. Toki has left because he has talked about the toxicity of matter. I am showing you another version of the same topic, and as you can see from the topic, and I'm going to talk about nickel oxide and how nickel oxide is for animal models will be presenting phenotypes that we can expect in the human being.
Next slide.
आपको मेरी आवाज आ रही है? ओके तो अगर हम अपनी जिंदगी को थोड़ा सा बोझ करें तो हर किस्म के दिन के साथ हमारे ह्यूमन पर वो छोटे से छोटे होते जा रहे हैं। आप कुछ अर्सा पहले की अपनी लाइफ में देखें तो आपके मोबाइल फोन बल्ब हुआ करते थे, आपके घर में टीवी हुआ करते थे, एलसीडी स्क्रीन, ट्यूबलाइट की जगह आपके पास एलईडी लाइट्स, आपके पास हर चीज बल्ब से एक नैनो फॉर्म के अंदर आ रही है। So we are living in a world of nanotechnology. We are living in a nano world. And from this simple picture, you can see that now the nanotechnology has invaded all parts of our life. It is not only in our everyday household things are made up of nanomaterials. Our industries are focusing on nanomaterials. Also, our health, our medicine, our treatments, they are now dealing with the nanomaterials. And a long list of nanomaterials are in our everyday life use. But the big question is whether there are all goods associated with these nanomaterials, or there are questions of biocompatibility, or there are questions regarding the toxicity of these nanomaterials that we are extensively using. So among the large number of nanomaterials that we are using, one of the very common nanomaterial is nickel, which is available in different forms. And these nickel-related nanomaterials, they are part of the batteries that we are commonly using in different ways. They are also used in electronic materials. We are using the nickel nanomaterial for the water purification. And if you move on to the next slide, the nickel nanomaterials, they are also extensively involved in biomedicine. They are involved in treatment, they are involved in the drug delivery, and you can see a long list of uses where various amount of nickel they are in our everyday life use in our medicine country. And as these nickel and nickel-related nanomaterials are extensively in common use, so we must know how they reach to the living system. And there are several ways in which these materials can reach us. We can take these materials to our digestive system whenever we eat something that contains nanomaterial, or we drink a liquid or material that contains nanomaterial, that will get entered into our system. We can have these nanomaterials within relation because a lot of nanoparticles they are present in the smoke and dust and in the air. And also these nanomaterials can enter in our system through dermal penetration. So whatever is the route, whether it is through food or water or air or through skin penetration, it will ultimately be reaching to our blood circulation. And if you move on to the next slide, because the remaining part I will be explaining in the next slide. But whenever something is transported to the blood and owing to their very small size, they can be either become the part of the cells that are present in our blood or that's what become serum. And we know that cell and serum, they are responsible for specific functions. Cells are responsible for gas transport, for the blocking, for immunity, and serum is actually our transporter, which is going to transport all good and bad from one part to the other. But the important thing is that all these cells, they will work normally when they will have a normal physiology. But we know that whenever nanomaterial they reach to a living system, they either act as an agonist or antagonist. It means in simple words, either they act as a receptor stimulator or they act as a receptor inhibitor. In both these cases, these reactions are unwanted because every cell has its own physiology to which it is working, and number physiology is normal, obviously cellular functioning is normal, tissue function and organ function is normal. We move on to the next slide. Similarly, when the nanomaterials they reaches the blood, they can reach to each and every part of our body, including our master controller, that is our brain. And being the students of neuroscience, we already know that the different parts of our brain they are regulating our different activities. Normal brain function simply means the normal progression. But imagine that all these different parts of our body that are labeled, they are supposed to perform different functions. When they will be receiving some unwanted nanomaterial, whatever is the source to which they are coming, they will be disturbing the brain physiology. And when the brain physiology is disturbed, it means our behavior is disturbed because some of everything that we do is our behavior. And in this discussion, my focus will be on the two aspects of the behavior. One thing is learning, and the other thing is learning. Learning is that thing that we do for the first time in our life, and when we repeat that learning, it becomes our memory. And obviously, the learning and memory formation as a cellular mechanism, and these cellular mechanisms, they need only fine-tuned chemicals to be optimal in its function. But whenever the nanomaterial will be reaching to the brain, they can affect the normal physiology of the brain. I will show you some interesting videos as well to give you an idea. Please move on to the next slide. Another important thing that we should learn or should remember is the generation of reactive species. Every living cell has to undergo metabolism, and when we talk about metabolism, it means production of the ions, consumption of the ions, and there is a very delicate balance existing for normal cellular physiology, where the ions, cations, and anions that are generated, they are enzymatically or non-enzymatically converted into compounds that are required for our normal function. But it is an established fact that whenever nanomaterial reaches to the system, they result into generation of unwanted ions. And these unwanted ions, they cause oxidative stress. Oxidative stress that is going to affect the DNA, RNA, and protein, because you all know that during the gene expression, the DNA, RNA, and protein, they get unstable. They are activated by enzymes or deactivated by enzymes. All these functions in which play a major role. So unwanted production of ions mediated by the nanomaterial, they can affect the gene expression. And when specific or general expression is disturbed, obviously the physiology is disturbed. Please move on to the next slide. So when we have a problem, we have a solution from the nature as well, and there are large number of antioxidants that are available in our system. From the list, you can see there are protein, there are non-protein antioxidants. Their task is to capture the unwanted ions of the product and to neutralize the oxidative stress. So I will be talking about three antioxidants that are present in our cell: superoxidase mutase and catalase that are involved in the consumption, utilization of hydrogen peroxide, and aldehyde, which is associated with the lithium peroxidation. Move on to the next slide. So the aim of our study that I'm going to share with you is report the biocompatibility of nickel oxide nanoparticle. We took albino mouse as a model, and all the experiments were sex-specific, that we have observed the effect of this nanomaterial in various doses in a gender-specific manner. Next slide, please. So the first thing that we performed was the synthesis of these nanomaterials that was not rather if I'm just quickly stating it. One of our collaborators, Professor Dr. Naeem Ashik is a very famous name in the field of nanomaterials. We have synthesized and characterized these nanomaterials. Next slide, please. And then what we did that we have made two groups on the basis of gender, male and female, and each group had three experimental treatments. One group was saline treated group, and there were two different doses of nickel oxide. They were used 20 milligrams and 50 milligrams per ml. And these nanomaterials were intraperitoneally injected, and these were injected for 14 days. And we have maintained two separate groups in order to show the effect of gender. Then at the end of 14 days of experiment, we keep on clicking. So we performed a series of behavioral tests, for which I will show you small video. Then I will be showing you the results. Then I will explain how we perform these. So we perform rotor rod tests, light dot tests, open field tests, and novel object recognition tests in order to show whether the nanomaterials are affecting the brain function or not. Let's see. We also analyze the complete blood count and compare it between different experimental treatments. Similarly, we determine various serum parameters that are basically showing the liver and kidney functioning test in order to show the effect of nanomaterials. And in the next slide, please, at the end of the experiment, we have surgically removed the vital organs, brain, liver, heart, lungs, and kidney of each animal. And we determined the three antioxidants that I introduced in the previous slide in order to see whether there is some change or not. Next slide, please. And then we applied one by ANOVA and followed by repeaters to compare the results. Now I'll take you through the results and some of the videos that I had. This is a chemistry slide showing that the nanomaterial that was synthesized was in one phase pure form. They were all having a particle size of 53 nanometers, which is considered as very small material that can cross the Kelvin space and can enter into the cell. Next, please. So we also measured the body weight because we applied the nanomaterial on a daily basis, 14 days on the basis of body weight. So we have seen that there is no difference on the body weight after 14 days of intraperitoneal injection. But in the next slide, we will see the differences observed in behavior and biochemistry. So this video that I'm going to show you is about the rotor rod test, and rotor rod test maybe you have seen it before or in some movies where the rodents are kept as pets. So this rotor rod test, if you run this, click this one. Click on this one, double click. So this is a test for the neuromuscular coordination. Double click. Go back.
Right.
फोल्डर में बने हुए वीडियो वहां से हम लोग करेक्शन है. So this rotor rod test is showing the neuromuscular coordination. Rotor rod लिखा होगा, those are the people. So we give training to the mouse that it hold it on the rotating axis. So you can see if the brain activity is normal, if the brain function is normal, the mouse will try to sustain on the rotating ground, which is like rotating at a specific frequency for revolution per minute if you run the other one. And if the brain is damaged, in this case due to the nanomaterial, the performance will be affected and you will see a different video now. So feel the difference that this animal is not able to perform normally because in the first video you have seen the mouse was running and trying to hold it on the rotating ground. And this shows that your nanomaterial has affected the brain function. If you go back to the presentation, please. So here you can see the result of this rotor on test. And the whole switching is self-specific. So in this side, you can see that there is a significant decrease in the male mice that were performing rotor test, and for the female, the difference did not reach the statistical significance. And you can see that the results were more pronounced in case where the high dose was applied. So move on to the next slide, please. In the next test, we perform open field test. I wonder if this slide will be playing for us. But you know that the rat and mouse, they are nocturnal animals, and they have exploratory behavior when they are kept in the dark places. So in this open field test, we introduce a mouse for 10 minutes, and the mouse starts exploring the whole area because it's its habit if the brain function is normal. But if the chemical has disturbed the behavior, obviously the performance will be disturbed. To go on to the next slide, I'm not sure if you can see this video or not. So when we perform the open field test, here we have observed some significant differences in case of female mice. And you can see that the mobile episode and the immobile episode, they were significantly decreased. It means change in the behavior of the mouse because exploring the areas in the normal condition is a normal tendency of an animal. So that was significantly decreasing in case of female mice. Next slide, please. And then we were also performing light dark box, and in light dark box again it's another aspect of exploratory behavior in which we have two chambers, one light box and one dark box, and as per their nature, the being nocturnal, the mice they prefer to explore the dark side. And also in these there's some of the reflexes that are the innate behavior of these rodents. They are very interesting. Maybe you have seen rats and mouse in your lab experiments or when you have kept them aspect that usually they stand on their hind legs and then they try to sniff their face, and this is called as sniffing reflex. And similarly, they try to stretch their body, and these are part of their normal behavior. And during these tests, we have observed that this structure kind reflex that has been significantly enhanced. And this reflex is enhanced, which is a sign of an anxiety that these animals they are not feeling normal. They are in a sign of decline. The next slide, please. So another test that we had performed was novel object test. That is a test for spatial memory. In the first, it has two trials. In the first test, we put two objects in two distinct corners of a chamber and allow the animal to explore. And in the second trial, we change one of the object and replace it with a novel object. And if the animal is normal in physiology and learning memory, the animal is supposed to explore the new object more because he or she will feel the difference that the environment will change. So next slide, please. So when we perform the novel object test, we observe differences in male animals, and you can see a lot of parameters they were disturbed. And these parameters were with the line crossing, were the two objects, time spent with the old object, time spent with the new object. And these results are indicating that this nickel oxide nanomaterial that has disturbed the spatial memory theoretic behavior of that. We move on to the next slide. So when we observed the complete blood count parameter, we did not find any significant differences for both male and female. And if we move on to the next slide, when we compare the serum parameter between male and female, between control and treated, we observed that ALT, which is a liver function enzyme, it was significantly enhanced in female mice, meaning that these nanomaterials were affecting the liver activity. Also, the albumin proteins, they were significantly reduced, and for the male animal, the urea levels were enhanced, indicating that some of the kidney function has been compromised. If we move on to the last part of my presentation, and then what we had done, that at the end of the experiment, we had surgically removed the organs, and we have determined these three antioxidant estrogen catalase and MDA, and we had observed a change in the level of these antioxidants. And as I have mentioned before, that whenever we expose the animals or living system to the nanomaterial, there will be generation of unwanted ions, there will be into oxidative stress, and when there is oxidative stress, obviously the antioxidant profile will also be changed. So we have seen a significant change, specifically in case of liver, heart, kidney, and brain, and these all are indicating that the nickel oxide nanomaterials, they are affecting the physiology and the behavioral activity of the animal, and that's specific to. If we move on to the next one. So we have concluded from these experiments that the nickel oxide nanoparticle, they have a tendency to affect the neuromuscular coordination capacity. We have also observed changes in the serum biochemical parameters and in the antioxidant profile of the animal. And these effects were sex-specific, being more pronounced in case of male, and these effects were dose-dependent, being more pronounced in the high-dose animal. And this, these experiments, we move on to the last slide. These results have forced us or compelled us to ask the other group to start the molecular studies for the nanomaterials, specifically for the nickel oxide, because we did not investigate the molecular mechanism behind it. We have studied behavior in blood biochemistry, but the result was interesting that what are the various genes, what are the various proteins that are upregulated or downregulated following the exposure of nickel oxide in different organs. And the take home message in the last slide, let's go back one slide. This is the take home message from this presentation, that although the nanoparticles have facilitated our lives to a great deal, but most of them are also affecting the functioning of the living system. And specifically in Pakistan, there is no check and balance. There are no safe limits that are, in my knowledge, that they are determined for a nanomaterial when it is introduced in an industrial product, or when it is introduced as a food preservative, or for the drug delivery. So there must be some mechanism, there must be a way out that we know the safe limits, we know the safe doses, we know the safe routes of application for these nanomaterials, because you can see around you that every day we are coming up with new sorts of cancer that are never heard before. We are getting the phenotypes that are getting more complex than the usual things. And all these are the side effects of different types of nanomaterials that we are either taking it through food, water, or we are inhaling them, or they are going in our body in our skin. So this is something about the, I would say, negative side of the nanomaterial. But we should have both sides of the picture. We are getting a lot of benefit from the nanomaterial, but we should be aware about their biocompatibility, and we must know about their safety. Thank you very much for your time. If you have to pay the question now or onwards, I will be available till the end of this month. I will be happy to pay the question.
Thank you so much. With one of their co-chairs, in share with them regarding the people on the floor.
I did not really want to, today, but I was wondering, I have little nanoparticle, which you said most to be brain. Because the blood-brain barrier is the limit of the intact blood-brain barrier is 8 to 10 nanoparticles. So if it's a bigger particle, how does it cross the patch?
Well, I would say one of the slides where I had shown you the chemistry of these nanomaterials. We had shown, we use the formula of the Kashmir formula that is used to determine the diameter. If the average diameter was 43 nanometers, but that does not know all the particles were. We were also determined this nickel in three different orders, not shown that I have to the years and that. So we have been measured at significantly higher level of nickel in the heated animal as compared to the so far. But we not included that to cover everything in these. And that goes very in line with the behavior of the patient because we have seen significant changes. But as I said, we did not check gene expression or proteins that are showing or that are showing increased immunity against the. So if someone will take this lead, it will be interesting. I can show because in the end we had placed some papers that we had published out in so the data is already published regarding molecular and biochemistry. If someone can try to find out
why do you believe you found out the difference?
It's very obvious because if we even implement on the human being as well, one chromosome is making a hell of difference in the normal wheat as well as in the physiology. And same is true for the model animals. So right for the last couple of years, we are working on our next classification. And we have not only seen the broad effects by the way, we have also seen the effects on the receptor expression and antagonist behavior of different receptors that are caused in the and both of them have been raised and really important why in the field and that is why the overall sizes are not saying the overall probably are not saying that the brain parts are different. The brain parts are same, but the physiology is different.
University, and I was really invited 2 or 3 days staying here. And you have done interesting study, but you have found this result. In one test, the females are most susceptible towards toxicity, and in other male having some this type of susceptibility towards toxicity. So again, we cannot conclude. You already have given the answer that which sector is more susceptible towards the nickel oxide nanoparticle toxicity.
Absolutely right. Your observation is very true and accurate. I will say that these observations are only for 20 and 50 milligram nickel oxide. Those nanoparticles that will synthesize by hydrocarbon mixing. So there are several different methods to synthesize the nanomaterial. There are several different routes to apply these, and there are several different roads. You will find some people have applied maybe 1 line or 1 some of them we have applied energy. And there is no such question not only for nickel oxide but for any nanomaterial because when you change the road, when you change the concentration, the whole chemistry gets changed. And sometimes the nanomaterials they are present in the form of plants. Where you can use different particles they are detected with. We cannot say that all house they behave in similar way, but in case of the chemical, and also in the technology field, we have to ensure that they are all written so that we can as close as possible. They will integrate, they will integrate the treatment or even if it's not a great and single animal, but as all we use are not same or animals are not same. We cannot, say that these are the ultimate results for people like that. I would say for my experiment, for my knowledge, for this situation, I think what we had these results are reliable, but maybe on different doses you get something.
Thank you.
No.
Hello. Thank you so much, Professor Dr. Mr. Gawan. Thank you so much, Professor Dr. Thank you for the
I want to thank you for the question.
Thank you for joining us for this session. So moving forward, I would like to invite our session chair, Professor Dr. Sayed in faculty of Life Health Sciences, Mobile University of Karachi. Our co-chair. You may continue. And I would like to invite our co-chair, Professor Dr. Hima Ikram, who is serving as an assistant professor at the Department of Biochemistry, University of Karachi. Thank you so much for joining us. So a little more about her. She has more than 40 publications, so they stated peer-reviewed journals, and that is a US patent on her credit. She has supervised 5 PhD and 4 MPhil students. Her area of research includes neurochemistry of addiction, depression, cognition, and memory disorder. Welcome, ma'am. So I would like to invite our presenters. I would like to invite on stage Mohammed Basmi from Al University.
Slide change कर
Lights.
And the thing I'm going to share with you is the carbon extract, which is actually the potential for the research capital. So this is also here. Surgery and model, everything evidence, and then I will discuss all the continuing of this study. So first of all, what is the serial and step? Actually, serial is a simple
any disease, but epilepsy has really tells you more time to go figure will be there. So when we discuss about this figure, epilepsy and neuron are increased so many possible. Most of the exactly main type of figures are observed in patients like only absence and malformation. Figures are present in the patient and the unprovoked figures now more unprovoked figures are present in the patient than the figure is the epilepsy. According to the International League Against Epilepsy, they have divided epilepsy into different types. Only the people like there. Yes. In here, let's say that
वो दबाओ, वो दबाओ.
नहीं नहीं अब हम
okay, when we discuss about this type, maybe focal, generalized, and unknown, but the epilepsy is classified on the basis of these figures. And physiologically, it is defined as different categories like genetic, increasing genetic, metabolic, infectious, structural, and immune. But our focus on is the resistant epilepsy. So, temporal epilepsy is one of the most common resistant epilepsy, which is known as TLE. It's a structural abnormality and it is a focal form of epilepsy in this impairment of consciousness. So, we note that in the whole, you can see that as a epilepsy, we focus on our epilepsy with the resistance, with the temporal epilepsy, with the epilepsy. Next. So, according to epilepsy statistics, in developing countries, the burden of disease are quite high as compared to just one, and in developing countries, Pakistan will be present. So, of the list, it's about 10 out of 1,000 patients, 1,000 people are epileptic, according to a survey in last year. In 2003, after the adult, we have presented that the Pakistan is of the list in epilepsy patients. And all around the world, 70 million people worldwide have this disease. So, what is temporal lobe epilepsy? In that, we all have temporal, you can see here, I have shown the temporal lobe in a brain, in which you can see the left one is the blue color is the normal one, but the red one is the seeing one. Next, please. Next. I can show you in a bigger picture. There's close one and the normal one. This close one is the most common drug-resistant form of epilepsy due to the hippocampal sclerosis. So one third of the patients continue to have seizures taking any anti-epileptic drug with and they have with temporal conditions have been observed. We can see the side effects of the epilepsy. So, different anti-epileptic drugs are available. So, if a patient is epileptic, then might be patient is a complex partial seizure and it's the part of temporal epilepsy. Then in temporal loop, there are two main types: the mutant temporal loop and unicortal. In a unicortal, this is the very rare one. And there is a very rare one. But in mutant temporal epilepsy, 80% of the TLE patients are an TLE, which leads to the hippocampus sclerosis. Okay. Then there are different anti-epileptic drugs are available. When we have given to these drugs, but this disorder is resistant to this epileptic drug. So this surgery is an option. But in surgery, we have observed that memory deficits have been observed after the surgery of the hippocampus sclerosis. So there is a need to explore the herbal interventions, the herbal medicines. Next. According to recent literature, there are a lot of herbs have been reported with anti-convulsant effects. And nowadays, we are we are doing research on the professional and chemically, which have been reported anti-convulsant effects. Next. So the aim of this study is to assistant drug treatment for the epilepsy, and the objectives were to install hand mount for the counting number of seizures in an animal model, to induce epilepsy in these animal models, then effect of herbal extract, behavioral and histological analysis, and then I will discuss about the return and continue. Next, please. Next. This is the overall methodology. It is not a simple procedure actually. It takes around 50 days of one lab. If I can start from 1 day of study of the animal and then go to the histology of the result of the day, it will take around 50 days of one lab. You can see here in day 1, if I have to do surgery, I have to give a 1 week of the recovery time, then use epilepsy with different chemicals, and then I have to wait for a latency period, the hippocampus will be closed. Then the herbal treatment start, and then on this time you see the EEG coding started, and we have observed the number of seizures 24/7, and then there's a behavior analysis, there's a transcription perfusion for histology. Next, and then we have to perform the proteomic analysis as well. Next. This is you can see the okay. Continue. In the last slide, we have performed the surgery, which is treated by now. This is the induction of the epilepsy. We have used epilepsy by pilocarpine, this chemicals. Actually, the death rate is quite high in these pilocarpine, which is the main issue. To reduce the death rate, mortality, we are using diazepam and other than one chemical to reduce the mortality rate. Next, please.
Next slide.
Next. This is the EEG recording we have performed. Next, please.
बेटा सुन रही हो क्या होता है?
The behavior analysis, positive test, and the novel test test, which are already discussed by my last colleague. Next, please. Consulted perfusion are performed to check the interest and to check the range changes. Next. This data will be analyzed by these procedures 1 and NOVA and SSS. Next. Due to time constraint, I will continue. This is a you can see the video. You can see here the seizure, and we have to observe 24/7. The number of seizures were counted by 2 independent researchers. Next, please. And this is the result. Next, this is the professional use seizure frequency. You can see here the line in orange, the line of the treated rat. The number of seizures is reduced but not significant. Same in the case with improved memory is improved but not significant. This is the depression cases. We have performed the 2 character tests. I have discussed in the last slide and there. And actually, so okay, this is the we have found significant results in CO1 region and DG region. We have found that these regions are significantly improved in the region. Okay, next. This is the another herbal we have treated nowadays. In this, we have found that the memory is significantly improved in the depression case, but memory is not improved significantly. Next, please. So the overall conclusion of our study is that treatment with zingiprophosphate can improve seizure, memory, and depression, but statistically not significant. And zingiprophosphate statistically significant reverse the hippocampus process specific in the CO1 region and D. And nowadays, carbon can improve memory, but not significant. However, it will use depression, which is caused by the epilepsy, and it is significantly improved the carbon extract. Next. I told you, thanks to all of the BBS team, BBS and Annual Neuroscience Conference who give me the chance to share my Thank you very much. I take any question, please.
So our next presenter is
Questions,
to learn from the I request all the presenters to please raise your hand and because we really need to move on forward to the second. Thank you so much. So today I'm going to share my research entitled single nucleotide polymorphism in iodothyronine dealdehyde 2G and their association with thyroid hormone levels in schizophrenia patients in Pakistan. Next, please. So, as my parents introduced, schizophrenia is basically a chronic mental illness that results in hallucinations and depressions. The patients, they lead their social life and they depend on others for their daily life. The prevalence is quite high in Pakistan and the rest of the world. Mortality rate is also increased in schizophrenia patients as compared to general population. Both environmental and genetic factors are responsible for the etiology of the disease. Next, please. Number of neurotransmitters are found altered in schizophrenia with dopamine taking the lead. The dopamine acts via binding to dopamine receptors, and the sensitivity and concentration of dopamine receptor is regulated by thyroid hormones. Next, please. So, a little light on the thyroid physiology. Under the action of secretory glands, thyroid secretes two types of thyroid hormones. The inactivated is the T4, which is secreted in major quantity than the T3, which is the activated form. Next, please. If we talk about the picture of the brain, thyroid hormones which enter in the brain, T4 is the one which enters in the brain. This T4 has to be converted to its active form so it can perform its role in the brain, which includes functional maintenance, cognitive abilities, and regulation of dopamine receptor sensitivity and its concentration. Next, please. The important point to note over here, the availability of active thyroid hormone, that is T3, in the brain solely depends upon the activity of iodothyronine dealdehyde 2 enzyme. Because in the serum, there are two types of enzymes, DI1 and DI2, which will convert the T4 into T3. Now imagine if T3 is present in the brain and there is no DI2. So you will have no T3 in the brain to perform its role. Next, please. Literature review has shown that polymorphism in DIO2 gene results in the reduced activity of DIO2 enzymes in the brain, leading to hypothyroid status in the brain, which will result in decreased cognitive abilities and increased sensitivity of dopamine receptors, which is one of the etiological factors for schizophrenia. Remember that this polymorphism has no effect on the serum levels for thyroid hormones because in the serum, DIO1 is present, which produces its role, that is the conversion of T4 to T3. Next, please. Further, it is also been reported that patients with this polymorphism, when they were given a combination therapy of antipsychotics and T3, that is the activated form, they respond well in response to their cognitive abilities. Secondly, the association of DIO2 gene with several neuropsychiatric disorders was reported, but its role in schizophrenia was not studied elsewhere. So, with this study gap, we planned our objectives as next, please. To study the association of DIO2 gene polymorphism, RS20 to 5014, with schizophrenia in Pakistan. We also plan to study the effect of this polymorphism on serum thyroid hormone level. The we plan was to study the correlation with this polymorphism and schizophrenia severity. And we also plan to investigate the correlation between thyroid hormone levels and severity of schizophrenia. Next, please. So those individuals which were diagnosed as schizophrenic under DSM-5 criteria were enrolled in the study. While age and gender matched controls without any neuropsychiatric illness were recruited as controls. If the individuals had schizophrenia along with any other neuropsychiatric illness, they were excluded. And the control with any diagnosed neuropsychiatric disorders or dysfunction thyroid, they were also not enrolled in the study. Next, please. So after taking the consent, questionnaire was filled and severity of schizophrenia was assessed using PANSS score. The peripheral blood was used to extract genomic DNA followed by PCR amplification of the SNP. The results of PCR were confirmed via gel electrophoresis and the samples were sent for sequencing. Back, please. The serum which was used for analysis of thyroid hormone profiles via ELISA, and all the results they were analyzed using SPSS version 21. Next, please. Now the results. One page, please. Only one. Okay. Okay. Now what we find out? Move. Next. Okay. We found out that males are affected with schizophrenia more as compared to females. Next. Then we also found the association of positive family history for any psychiatric illness with schizophrenia, showing that schizophrenia has a hereditary nature. Next, please. Due to decline in cognitive abilities, schizophrenia patients are unable to attain higher education status. Next, please. As they are unable to fulfill the requirements of a married life, so schizophrenia patients have increased divorce ratio than the normal controls. Next, please. Analysis of the sequence analysis of electropherogram showed all three genetic variants for this polymorphism, with TT being the wild one and CC being the mutated genotype. Next, please. After now, statistical analysis of the data showed association of genetic and allelic polymorphism with schizophrenia, with reference allele higher in control group as compared to the cases. Next, please. The next objective of our study was to find the association of this genetic variant with the severity of schizophrenia, and subscale analysis shows that none of the PANSS score was associated with this genotype variant. Next, please. The next objective of our study was to analyze the effect of this genotype with serum thyroid hormone levels, and what we found out was, next please, irrespective of the genotype, higher T3 levels were reported in control group, showing that this polymorphism has no effect on the serum thyroid hormone levels, whereas it might affect on the brain thyroid hormone levels, which cannot be detected via serum. Next, please. The next objective and the last objective of our study was to find the correlation of thyroid hormone profile with the severity of schizophrenia, and we did not find any correlation with the serum thyroid levels with the schizophrenia, because what is going on in the brain is not reflected in the serum. Next thing. So to conclude my study, gene polymorphism RS225014 is associated with schizophrenia, but it has no effect on serum thyroid hormone levels. It might affect the brain thyroid levels. Next, please. So, the future researchers studying the effect of PiO2 on brain thyroid levels in the CSF is highly recommended, and further application studies with higher sample size is also recommended to validate these findings. Next, please. These are the references. Next. I really thank Higher Education Commission to support this study, my supervisor, Dr. Palina, and my research for the study. So let's try to find out your contribution. And in the end, I would like to thank all of you for your time and attention. Thank you. Now I would like to invite the Farah Fahim from the University of Karachi for the next presentation. Dr. Fahim. Okay, so we'll move on to another presenter. The next one is Dina Hassan from University of Karachi. Unfortunately,
see so many good faces over here. Majority of them my students. So, today I will take part of my work, entitled Inferring Protein Expression Alteration Instigated by Moving Chloride and Degalactose Induced Oxidative Stress. And let me introduce to those who don't know me. I'm Dr. Veena Hassan, Assistant Professor at the Department of Biochemistry, University of Karachi. The purpose of selecting this topic was because for a couple of years I've been working on Alzheimer's disease during my PhD work. Alzheimer's, it's an age-related neurodegenerative disorder that results in neuronal loss, class, and tangle communication. Variety of symptoms are associated with this disease, including memory loss, change in personality, poor decreased judgment, disorientation, time and place, forgetfulness, misplacing things, problem speaking, difficulty performing familiar tasks or routine activities. Several environmental factors are actually responsible for developing this disease, including exposure to certain toxic metabolites, air pollution, physical activity, psychological stress, and certain nutritional factors. This disease actually this disease usually affects a couple of regions in the brain, especially the hippocampus, amygdala region, the cortex of our brain, and the cerebellum. Next page. Actually, with the passing of time, the people that are being affected by this disease are growing in number. And since there are multiple factors that are responsible for the development of this disease, one of the factors for the development of this disease is oxidative stress. This oxidative stress can be caused by a number of factors, including the mitochondrial dysfunction, certain metal metabolism or accumulation of certain metals can result in oxidative stress in our body. Inflammatory symptoms can also lead to increased oxidative stress. And besides this, there is an ability that the hyperphosphorylated tau and A-beta accumulation in the brain, they may also lead to oxidative stress. And in turn, oxidative stress can lead to increased A-beta accumulation, which is actually the prime factor responsible for developing Alzheimer's. Next, please. As a result of oxidative stress is because of certain molecules that increase in our brain and blood that may act as an indicator for the disease. Lastly, aluminum chloride is being selected since it produces neurotoxicity, and neurotoxicity can result in neurodegeneration as well. Aluminum is the first most abundant metal that is found on Earth, and it has been used commonly in our society. And it is similar in size as that of other metals like iron in our body. And this aluminum is thought to change the permeability of blood-brain barrier as well. Next, degalactose, as we know that it's a monosaccharidal piece of, but when it is provided in pipes, it may be converted into a hydroperoxide by galactose oxidation. This results in the formation of superoxide and free radicals of oxygen, increased oxidative stress in the cell. And both aluminum It's therapeutic because the only thing we want to accommodate is the severe disease therapy for patients and many other like it results in around 13 days to different further release more than 130 days. Next. This is overall technology and how technology is used. When a person was born, when doing support of the users, like especially propensity, where they create microorganisms. This is the main thing that is by the way, and next. This is like when it is presenting overall on the technological dimensions of the scope. Next. What everyone can learn the main result or the main consequence of unique physiology and ultimately result in therapy and job of these functions and specifically abilities of brain. So when you clinical research, what is the nature of the body? We have neural sensors in the brain. Normally, the neural sensors are in default state, but whenever there is connectivity or any kind of like inflammation and instead, there is the activation of these neural sensors, these integrating these sensors in these neurons. And these neurons, these affected behavior suffering from any disease, right? So what are the treatment strategies available for the for this therapy? Very truly speaking, there are not any effective strategies that we have protected treat self-spinal family. But the instinct or the classical doctrine we have in the accident of behavior by which the blood clot is removed from the blood vessel. And then other approach is the tissue plasmid activation. But the use of tissue plasmid activation is very important because the therapeutic window is very low. It's about 4.5 hours. Right? The only effort to treat insult is it depends on the various factors. Like in the current era, the sensor therapy is very fascinating and available for the research can be treated of different disorders. Next, there are various types of sensors. On these sensors are the ones which have the ability to see the red cells and damage next. So what is the main working mechanism or the principle of using sensors to achieve the measure of data? These are the physical associated incident variation as a result of performation testing. We have a direct magnetic field with the performance and information cascades and various other mechanisms are very in the week of circuits, which result in degeneration of the part. Next. So we can use analysis in the nature as well as we can investigate the best strategy to use the fluid whereby it's various technical and effective are used in scientific ability to further understand for their innovative effects. Next. So digital-based scientific approach specifically for the neurology and are either deploying the birth presentation which is performed diffusively performed in our lab. Next. We perform all kinds of work which are which are affected in the starting protected and also perform the video work whereby the sensitivity or are concentrated in the end model. Next. So how do we select biomolecules based on their various features like this case? We have selected various biomolecules, but we are presenting one of them. Biomolecules alpha-pointing active is very powerful features like expansion and it also has a same and why we have active compounds for treatment of brain damage. Next. So here is the method for all overview of the research work and then we are specific source like better and you can slice and often check the specific networks of count is that create and if we can perform after the results are analyzed whether we have differentiated for the specific or not. Once we confirm that yes, the cell for the differentiated for the specific, we transform them into the another model. In this work, I have established the right model of central premium for the cortisol and subsequently the MSC to their and I could read the reciprocal. Next. This is the overall graphical pictorial representation that how we can see the cycle from bone marrow. Next. These are the propagated once they are isolated, they are propagated. And this is the pictorial representation of the MSC at the different time points. Next. After the isolation and propagation, we characterize this whether the cells that we have isolated are being famous centers or not. And for characterization, we offer the three different methodologies using immunocyte chemistry. Next. Next. These are the chemical results which indicate the positive expression of MSC specific marker and the negative expression of the specific marker indicates that the cells have been differentiated, the cells are being sent sensor. Next. This is next. This is represented by the flow cytometry. Next. And this is the characterization by trial differentiation potential. Next. Next. For the biomolecule, we analyze a dose which tells us that which dose should be used for reconditioning. Next. Next. This is the result that we have performed differentiation analysis by using the static dose. And you can see that in the control analysis, there is no any differentiation. However, in the field analysis, it shows differentiation towards the normal areas. Next. And the gene pattern analysis indicating the protein pattern analysis indicating next. Next. These are the special protein for the non-specific markers. The liver result we have established a model of the red heterogeneity by the QGO model. Next. Next. Okay, after the establishment of model, we perform like whether the model has been established or not, and this for this we analyze the physical science symptoms after establishment. You observe that it suffers from the high density mode, meaning you observe also the gradual darkening of the erythema and the myelin. Next. This is histochemical analysis indicating the brain damage. Next. These are the hypoxic inductions and inflammatory mediators. Next. The inflammatory mediators was also present in the disease rat compared to the normal. Next. These are the histological profiles indicating the damage in the tissue brain in both cortex and thalamus compared to the normal control. Then we perform the transplantation. People who give us a name. And these were transplanted by the tail vein. And we also had a regeneration of the transplantation by all these techniques. Next, the PDC staining indicated the region, the recovery of the damaged area in the normal analysis and the APMSC transplanted group compared to the disease group. These are the histological analyses. We observed that the disease control having a severe degeneration inside the brain tissue, whereas we were recovered in the normal and the treated analysis. Next. We have consequently the by also indicated the upregulation of the mediator into the disease control, whereas these were downregulated into the transplanted groups. Next. Okay, so overall study concludes that the MSC after the conditioning has potential differentiation into the normal lineage. And when these MSCs were transplanted into that they effectively regenerate the brain damages. However, the precondition MSC shows more good for the better results compared to the native MSC. And thank you. Thank you so much. And now welcome the comments to the program. As well as any questions or discussion will be covered by this. Thank you so much. I don't have any specific question, but I can see lots of students here. And a journal, you can say statement or one thing. Whenever you prepare your presentation for a scientific session,
please keep in mind that they should make sure to be precise and to the point. Because if you are not doing this, this is a time mismanagement and this is not the goal. And because in my opinion, time management is the key of success. So please next time you should be accordingly.
Presentation were very nice. Some questions, questions from the first presenter, Mr. Leslie. Okay, so one thing of question is, you have worked in epileptic models, right? And you mentioned surgical. So, you prepare surgical, as you mentioned, what I perceived from your presentation, when for surgical, animal as well as people are and models. So, if you compare, so the
Same model.
both strategy is the same, because that is what I want to hear, because chemotherapy alone is also used for the induction of what is it better in future if you because most of the people working on these epileptic models, you know, much specifically like surgical process. Because they need expertise in post surgical chancellor here. So for beginners like cancer students, research students, what do you compare surgical models with philosophic and fixed segment models projects? Or have you done it before?
Yeah, we have done it, and we have used surgery before, and then we have used epilepsy while biochemistry.
You're not getting my point. Separate two separate group.
Same group.
Yes,
Yeah.
what I am suggesting that wouldn't it be better that if you compare surgically induced and philocarbon induced epilepsy animal models to see is there any difference of
Epilepsy is not used by surgery. We have surgery for the counting number of seizures.
but you can can't you count the conversions, number of conversions?
Yeah, we have count the
Okay.
number.
Okay.
Surgery is done for the number
Can't
of
you
counting. Yeah.
No.
Surgery is only by biochemistry.
Okay, then what you have performed post-pill test, right? So depression, so you were working on comorbidities.
Yes.
Thank you so much. Another question is don't basically for someone presenting the work on and moving to like ALC or C remember
Excuse me, madam. Dr. Bina, there is a question from sir.
Yes.
Yes,
Okay,
sir.
okay. So my question was why we need to have surgery for CC down there? Did you implant an electrode? And were there any surgical seizures which were not expressed physically and you only had an epileptogenic activity without any physical expression?
No, we have surgery and we start hand mount on the in the garden of the brain. Then we need to take in our animals, we have to attack and then count over 7 after the 2 weeks of the body. Then we have to count 24/7 analysis to count the number of seizures.
What I'm saying is, if we need to have a surgery to implant an electrode, couldn't we do a video recording of the same mouse and physically count the number of seizures you had in those 7 days?
They cannot differentiate between the two regular movements and the seizures. Without the EEG. The mouse has general shaking kind of movement from time to time just to clean itself, right? But in a myoclonic jerk, on the other hand, that is epileptic. So you have to have EEG finding for them. Otherwise, you cannot claim that what you just saw was a regular activity or was it a seizure.
All right.
Can I add something?
Yes.
We also have worked on animal models of epilepsy and scheduled conversions, scheduled very epilepsy. And one thing is that like if you have been largely electoral, it puts sense on my initial level, maybe worker who is sort of sensitive, but you should focus because most of the papers being published on epileptic and epileptic effects in this conversion. Physically, in now,
Remember,
which are saying it themselves, that is called losing, which is part of IVC syndrome, and that is differentiated. It is different from the epileptic.
Remember that there are 3 types of seizures. So we have what you just mentioned was a tonic-clonic seizure. That is easy to spot. But if you're talking about, let's say, a absent seizure, you cannot not do it with eyes. It's just not possible. Similarly, myoclonic jerks, there are very different movements from time to time, which cannot happen. Now, if you do a surgery, yes, there are chances that you can damage the brain, but that is why you have a control for comparison. So that is why a surgery is important in order to have a definitive fact that you just saw a seizure and not an abnormal or normal activity.
Yes, just to take it as a positive suggestion. And next time it would be very nice because we don't have surgical facility. Very nice if you compare the 2 models because pilocarpine means epilepsy very easy to maintain. So it would be very nice to see that instead of logical comparison if you could do.
And besides the point, MAM surgery itself will induce seizures in some cases. So wouldn't it make more sense if we avoided surgical procedure at all if we were studying the seizures?
So, epilepsy is very close to my heart, that's why I'm the thing is that definitely, when you go in and drill a screw into the skull of a mouse, there is, or a rat, there is a chance that you can cause a stroke. Now, having said that, that is why you have a control in which after doing a surgery, you keep monitoring that and see whether it has a seizure or not. And if there is an abnormality, and let's say that the mouse has reduced activity or anything, you can take that away. You just want a normal mouse to have EEG recording. And this is a very common feature that has been around for about, what, 40 years now? So, and in fact, now they are also having EEG electrodes, which can be done, wirelessly. So you simply put that and leave the rat in its cage. Now, surgery has its own risks, but that is why the control is there.
At the expense of time, ma'am, just one more elaboration. Being a neurosurgeon, that's close to my heart as well. The point was, normally in people, we record epileptogenic activity from the surface of the scalp. We don't always have to drill a hole and put an electrode in. Can't we do that on a mouse without surgery? Yes.
The skull is very small in the mouse. So on top of that, if you put, you cannot get it. Now, in humans also, you would accept that intracranial EEG is much more specific in terms of the space where the seizure has originated. Now, in terms of over here, what has essentially happened in case of a mouse and a human, what is happening is that you make 4 burr holes, right? And you put a screw which is touching the surface of either the meninges or the brain. So an ideal surgery would not cause a stroke or death. Now, without that, first of all, the skull is so small that you cannot put an electrode over there. And it will fall off basically. And that is why it is just not available by any company or anything.
Thank you so much. And now I would like to invite on stage Professor Dr. Farhad Bhatti and Professor Dr. Nasir Awam to present to Professor Dr. Oh my God. Because there are some students coming from Pakistan and they do not belong to Karachi with the king for this conference and idea is school history, so we would like to call them up on stage so that we can present the certificates. So I take the names. The first is Waqaf Ahmed. Next would be Rabi Tariq. Also next is Maryam Ujjar. Mohammed Asif.
Atif. Atif.
Mohammed Asif.
वॉलंटियर्स के नाम लोगे
There are certain challenges that I really would like to highlight for all the participants over here. Please take note of it. You all have to gather back tomorrow at 8:30 sharp. Bring all your cards rather than giving to you along with the class. Together participants, the presenters, please take care of it. We will be having a closing session tomorrow with more interesting talks and presentations. The presenters must come tomorrow as the best poster will be announced then. So this is going to be really exciting for everyone and we'll be expecting all the students here and people of the best poster certificate. The oral presenters are requesting to stand their key speeches at 9 Neuroscience Conference at gmail.com. I repeat the email address, please note down. For all oral presenters, we all are requesting to stand their key speeches at 9 Neuroscience Conference at gmail.com. Anyone who has the email address, please, you can coordinate in here for volunteer to get the email address, noted down if there's any speller or anything that you want to make sure of. And, we're looking forward to tomorrow's session, and thank you so much, and thanks for all our respected. Before we would like to get the speakers and then there is another over here in the class, so we can take a very number